the most important topics in terms of software testing and in terms of your ISTQB examination also. All right. Okay. So, but before we begin, right, let's do a quick case study as we always do. So imagine you are a coordinator at a community center tasked with managing event registrations, right? So there are some events that you need to register for, right? Your center hosts various events, each with its own unique identifier, name, date, and capacity. So each event has a name, it has a date, it has some capacity, and its own unique identifier, right? Now, people register for these events, and you need to keep a track for the registration. So people are coming to you and they are saying, I would like to register for this particular event, or I would like to register for this particular event, right? You need to keep a track of it, right? So how will you model, right? How do you think you can use, what kind of software tools can you use, or how can you efficiently manage this event registration, right? How can you store that data to efficiently manage and keep track of all the registrations? Okay, what do you think? What all can you use, right? Give me in the live chat, tell me in the live chat, what all softwares can you use, or what techniques can you use to efficiently manage the event registration data? Valentina says, if you say Excel, I quit the meeting, right? Valentina, right? Yeah, see, that is the most basic part, right? In database, we'll come to more advanced database, but Excel is like the most preliminary form where you go to store data, right? So yeah, you can think of Excel, right? You can think of Excel. Uh, we'll go into SQL, right? Don't worry, but yeah, that's the basic, right? Excel is very basic, all right? But yeah, you can, right? You can say that, right? So whatever comes to your mind, because right now you're not expected to know SQL or any other types of database, right? So right now you're not supposed to know that. Okay, if you know it, great enough, but at this stage you're not supposed to know that, right? So tell me, right? Tell me what comes to your mind, right? I'll take Excel as an answer, right, Valentina? That's a correct answer, right? You can use Excel to manage, but again, that's software, right? How do you still efficiently store the data in Excel or any other software, right? What other softwares can you use, right? Jordan says proceeds to say Excel 17 times, right? Okay, sorry, right? Yeah. Okay, so tell me, right, what are the softwares from Excel, right? Apart from Excel, what other softwares can you think of? Jordan, now, since you have seen in the live chat, right? Tell me, what are the software, right? What software? Think of any software, right? Think of any software that you can store data, right? You see, ultimately, it's about database, right? So it's data. Okay. Jordan says working with SQL, right? Correct, right? Correct. We will use SQL, right? SQL is correct. Okay, you can. Apart from that, right? Apart from that, because right now you are not. We are not starting with SQL, right? So we will move towards that. But before that, right? Before that, someone, right? Someone who does not know SQL, right? So they are at a community center. They don't know about SQL, right? And they're trying to figure out how do we keep the data. Okay. So what can you suggest to them? Valentia says, I can't recall what we used to use before Excel, right? Yeah, Valentia, you could use see, notepads, right? Notepads were there, text, right? So earlier we used to do in handwritten, right? So you used to have a diary, and in that you would write down. Okay, so someone comes to you and they say, I want to register for this event, right? And they'll write down, they'll make a note of it that this person had registered for this one. Okay, so that was before computers were there, right? And then we started using, let's say, text-based editors. Okay, you could use notepads, okay, or other text-based editors on the computers. Then came in Excel, right? Excel, and Bino says Google Sheets, right? Yeah, Bino, Google Sheets, Excel, same, right? One of the same things. Okay, so yeah, perfect. Okay, Ines says there used to be Microsoft Access, but I never understood the program, right? Great one, right? Ines, yes, right, that is also correct, right? Microsoft Access was also there, correct. And yeah, Jordan says Microsoft Oracle, Tableau. uh, Jordan, Tableau is for the visualization of the data, right? Not exactly for the storing of the data. It's to make the visual sense of the data, right? So that is what Tableau is for, right? Power BI and Looker, same thing, okay? MongoDB, right? Yeah, MongoDB, I'll take MongoDB, right? Because that is no SQL, right, Jordan? So that is correct, right? MongoDB, great. It's wonderful that you know that, okay? So Valentina says, yes, but always in the table way, right? Yes, Valentina, that is the keyword, right? That is the keyword. You represent it in tabular format, okay? And We'll see, right? I'll show you an example. Okay. So Jordan says, of course, AWS server, right? Yes, yes. So what happened was after Excel came in, then you had databases, right? Databases came in to the picture, and then you had this cloud computing. Cloud is where AWS or any other cloud provider, Google cloud provider, they abstract the storing part, right? And they take it in the cloud, right? And they make you pay as you go. So earlier servers used to be, right, you pay for the entire 1 month. Okay. And even if you're not using it, you pay for the entire 1 month or for the entire year, right? For the entire capacity that you have used for. Okay, then AWS came in and cloud computing came in and they made it as pay per go, right? How much resources you're using, you'll pay that much. Okay, so yes, correct, right? Valentina says easier to store visually infos, right? That is correct. Jordan says you can integrate SQL into Tableau, though. Yes, Jordan, you can, right? You can. That is correct. Okay, perfect, perfect, awesome. So great answers, right? Great answers. So these are the softwares you can use and efficiently, right? How do you efficiently manage the event registration? Okay, so I'll show you one example, right? So yeah, this is your typical Google sheet, right? And Excel, right? You can think of it as Excel as well. Okay, so the point here is you store it in tabular format. Okay, so if I want to store event data in tabular format, what I'll do is I'll create a table for events. Okay, so like this is a table for events, right? One spreadsheet for events. And here what will I store? I'll store the ID, I'll store the name of the event, I'll store the date of the event, I'll store the capacity. Okay, so ID is actually the unique identifier. So anyone coming to me was saying that, okay, I want to register for event number one, right? Or if they give me the name, I can have the corresponding ID. Why do we need this ID? Because the name can be same. Any other event can have the same name. Let's say event A, right? So two events can have the same name, right? Maybe they're happening in different years or after a few years, right? The event name can be same, but the ID cannot be same. So ID is the unique identifier, all right? And each row, right? Each row is a record. Okay, so each row is for one particular record, right? So for ID, so this is one particular event. Okay, so ID is one, right? Name of the event is, let's say, event A, date is 4th September, right? 25, and capacity is, let's say, 500. Okay, you want to add in another event, you say 2, right? ID is 2 for event X, 7th September, 300 capacity, right? So ID number 3 is for the next event, right? So like this, each row is representing one particular entity, right? So this entire thing is one event. All right, now there are people coming to us, right? People are coming to us and they want to register for it. Okay, now how do you efficiently manage that? For that, what you do is you create another table, you create another separate spreadsheet, and in this, now you take in the people, right? Now you take in the people here. So let's say the first person comes to me is Alex, right? I will store a unique ID for Alex, right? So whenever Alex comes to me, his ID is 990. Okay, so Alex comes to me and he wants to register for event number 2, right? So he'll give me the name. Let's say he gives me the name that I want to register for event X. Okay, how will I store it? I will come here and I will say that, okay, event number 2 is where Alex wants to register. Okay, then John comes to me, right? John comes to me, I give a new ID 991. John comes to me and again he wants to register for event number Y, right? X, right? Event number X. Okay, so again the event ID is 2, so I will say that, okay, he has been registered for event number 2. Okay, same way Alicia comes in next, right? I say event ID 1, right? This ID is the corresponding ID for the event. So if you want the information of which event has Alicia registered for, what we do is we look at the event ID. Okay, event ID is 1. Then I'll go back to my events table and I'll see, okay, where is event ID 1? Okay, event ID is 1 here, right? Then I can see all the details of that particular event. So you can have more columns, right? You can have more columns and more data. So that is the data for event ID number 1. Right. So that is how you connect tables and that is how you can efficiently store the data. Does it make sense? Does it make sense? This is the very essence, very basics of how you can tabularly store data, right? Okay, Valentine say, I realized how older respect to Jordan I am. Okay. Okay, makes sense, right? Does it make sense? This is how you store tabular data, right? You want to add in more information, you create different tables, right? You create different tables and you connect with them. Okay, so that is tabular, right? This is tabular. What you have is rows and columns. That is the key point that I want to highlight here, that you have rows and columns. Okay, and this entire thing is known as one particular table. All right. Anyone, any questions, any doubts so far? Perfect, right? Perfect. Awesome. I don't see any doubts, right? Great. All right. So how could you, second question is, how could you strategize to optimize data management process and ensure seamless coordination among different stakeholders involved in the event of the organization, right? So how can you strategize to optimize the data management process, right? So for that, right, for that, see, how do you optimize this management? See, right now I have used this Excel, right, spreadsheet, Google Sheets. Okay, now it is not optimum, right? It's not efficient. Why? Because if let's say there is another interface, right, and people want to take data from here and display it on the website, right, that event number A is on so and so date, right, and they want to display it on the website. So this is not efficient, right? This is not efficient, right? That is where databases come into the picture, where the data is stored in a database and you can use something like SQL to get the data from there and display it somewhere else, right? So you can fetch the data, you can display it, and you can manipulate the data. Because right now if I want to change something, let's say I want to edit this 500 to 600, I have to manually open the spreadsheet. I have to come here, I have to click on this, and I have to change it. Okay, so there's no way of automating it, or there's no way of actually using, let's say 300 people have registered, so now the capacity pending to us is only 300, right? So you cannot do all those calculations, right? All that is not possible. Okay, so therefore it's not optimum, it's not efficient, right? Now what you can do is you can use SQL or databases which can help you in this efficiency, right? Valentina says no, because they are not connected, right? You can't access edit to events table from people table, right? Correct, right, Valentina? Absolutely correct, right? Absolutely correct. 100%. All right, so this is where your SQL and databases come into the picture, right? Now let's go into the introduction, right? So imagine again, imagination, right? Hold on to your imaginations. You are tasked with organizing your home library, right? Now you have two approaches. You could meticulously categorize each book alphabetically. So you have a library at your home, and you can categorize the books alphabetically, making them easy to locate, but potentially missing out on the broader context of the subjects. Why? Because if it is alphabetically, then it's not subject wise, right? You don't have a separate segment for, let's say, fiction, for non-fiction, for philosophy or economics, right? You don't have separate segments for that, right? So you could arrange them thematically, right? So you can have separate racks. So if you're not doing alphabetically, you can have separate racks, or for separate compartments for different themes, right? So that fosters serendipitous discoveries, but potentially causing a bit confusion when searching for specific titles, right? So those are the two approaches that you can take. Similarly, in the realm of databases and data management, there are different approaches, with SQL being at the forefront, right? SQL is very popular, one of the most widely used database formats, and there's no SQL also, right? Something known as no SQL and SQL, right? So we'll talk about both of those and what is the differences between them, and we'll work on SQL. All right. So SQL allows you to interact with the database efficiently, querying, updating, and managing the data. This is the importance, right? This is the importance from your typical spreadsheet or Excel based format, right? Why? Because SQL allows you to interact with the database efficiently. You can query, you can update, and you can manage the data that is there inside it, right? That is the reason why we prefer SQL. Okay, you can either take the straightforward route of querying specific data points directly, or you can dive deeper into relational aspects, joining tables, uncovering insights that might not be immediately apparent. Right, don't worry about joining the tables. We'll do that in the next lesson that we have, right? We'll do into joins. So just like organizing your library, mastering SQL fundamentals involves understanding the balance between precision and exploration. It's about knowing when to execute straightforward queries for quick results and when to delve into the relational intricacies to unveil hidden connections. Okay, like I showed you, this was a simple connection, right? The ID over here, the event ID over here is simply connected to the registrations over here, right? So here this ID is connected to that particular table. Okay, but you have more complicated connections, right? As you see more databases, you'll see that the connections are more complicated between the tables. Okay, and that can unveil some hidden connections. Okay, so as we embark on this journey through SQL fundamentals, let's explore both the direct path and the relational databases to empower you with the skills needed to navigate the vast landscape of data effectively. Okay, so basically in this lesson, what we are going to do is we are going to explore the fundamental concepts of databases, examine the role in storing, managing, and retrieving data efficiently. Our objectives, right? So our objectives basically is to understand the basics of database system, what a database system is, how does it work. We need to explain the difference between SQL and no SQL, right? What is SQL, what is no SQL, and the differences between them. Okay, you should be able to identify the different types of database models and their applications. So we'll discuss about a few different types of database models and which particular model is used in which scenario, right? And not in every scenario you can use tabular formats, right? Tabular formats of SQL is not efficient in all scenarios. Okay, we'll talk about that. We'll talk about that in a few minutes. Okay, after that, you should be able to write basic SQL queries to retrieve data from a database. So we'll write some queries, right? We'll do some lab exercises and some practice questions to look at how you can create SQL queries to get data and how you can update database, basically use the CRUD operations, right? CRUD operations is what we'll discuss on to manage and manipulate data within a relational database. Right, so these are the objectives for today. So let's get started with this. Okay, any questions so far? Any questions? Let me quickly look at the live chat. Anyone, any questions, anything? Feel free to post in the live chat, right? Do you get any questions or something? You don't understand any part, feel free to post in the live chat. I'll be monitoring it. All right. Okay. So what is a database, right? What is a database? So you tell me, right? You all tell me, what do you think now that we've discussed the introduction? Tell me what, according to you, is a database. When you hear the term database, what do you think of it, right? What comes to your mind? That what is a database? Valentina says a storage system, right? Correct, Valentina. That is correct, right? That is correct. Absolutely. Ultimately, we are trying to store the data, right? So that is exactly a database, right? Good point. Okay, Jordan says place where data is centralized and stored, right? Jordan, correct, right? Correct, right? So it's a place where you want to store your data, right? You want to store your data and centralize. Yes, right? That's a good term, right? Jordan, very good term. It should be centralized, right? Because all your clients, right, all your devices can access that data. Okay, if it is not centralized, then you cannot access it. All right. Okay, Ines is typing, right? Let me quickly see what Ines is typing. Ines is a collection of data stored for easy manipulation and retrieval, right? Perfect, right? Perfect. Yeah, absolutely, Ines. That is correct, right? That is correct, 100%. So it's a system, right? It's a system. So basically database is what, when we talk about the database, it's basically two parts, right? So there are two things. One is your actual data, right? So one is the actual data, which is organized collection of structured information or data typically stored electronically in a computer system. Okay, like this data that I showed you, right? This is my data. Okay, I want to save it. Okay, that is your data, right? So that is number one. Number two is a database management system. Okay, so there has to be a management system which will help you in managing that data, right? To store that data, to manage the hardware, to write the software part, right? The language, let's say SQL, right? SQL is a language. Okay, it's actually structured query language. Okay, so you write that language. Okay, so DBMS, right? The database management system incorporates all that. So apart from the physical data that you have, right, the actual data that will be stored in the hardware, that with the database management system, those put together, right, both of those put together is what we generally term as a database. Okay, so what you all were talking about is the first part, right? That's the first part. That's the data that I want to store. Okay, encapsulating that, right, encapsulating that is the database management system, right? You'll say, what is this database management system? See, it is basically, right, database management system is basically an entire system that serves as an interface between the database and its end users or programs. So let's say I'm writing some program to access the data, right? Now that acts as an interface between the actual data and the user. Okay, for example, right, see, I'll show you one diagram, right? Look at this diagram. Okay, so let's say this is your laptop, right? This is your laptop and this is the client, right? Now let's say you're logging in into, let's say, amazon.com, or you're logging into some particular website, right? When you log in, what happens, right? This client, right, this basically a laptop, mobile device, or anything, right? That's a client. Okay, that sends a request, right? That sends a request where it sends a request to the server. right, to the application server. Now, what is the server? Server is a place where the developers have written the piece of code for that particular, so let's say for Amazon, right? So they have written files, right? They have written files of pieces of code, right? And those files are residing over here, right, in the server. Okay, so let's say I have written a particular file for the login, right? So the logic for logging in a particular user is written in a file, and that file is stored over here. Okay, so when you put in your username, password, and you click on login, right, what happens? A request is sent here, right? When the request is sent here, it's a login request, right? So that particular file, mind you, there can be hundreds of files here, right? So I'm just talking about Amazon. So my site is amazon.com, and in that site, right, in that site, I can have multiple files. Okay, one of the file is login, right? Login.java, let's say, or login.python, right? Py. So those are the backend languages. You can have Java, Python, PHP, or whatever language you're using. Okay, so you have that, let's say, login.py, right? Login.py is the Python file. Okay, now inside that Python file, right? Inside that Python file, somewhere I will write, or the developer must have written SQL code, right? They'll write some SQL piece of code. What will that SQL piece of code do? It will go to the database here. Now, this is the database. Okay, this is where actually the data is residing. Okay, so here in my Python file, I will write a piece of SQL code that will do what? That will go and fetch from the database that, let's say, what is the password for this particular user? Let's say username is Alex, right? What is the password for Alex, right? The database gives a response. Okay, it gives a response back to that particular Python file, right? Login Python file that I have. Okay, now inside that Python file, now I'll again check, right, whether the password that the database has given to me and the password that the user had sent to me here in the request, right? The user sent me a username and a password, right? I'll compare both the passwords. Is it correct? Right? If it is not correct, then I'll send back that login is failed. Or if it is correct, I'll send back login is correct, right? Login is successful. All right. So the point here is that the Python file that I had, inside that I'm writing SQL piece of code or any other language, right, for managing this data. Okay, to fetch the data from here, I'm writing some piece of code. Okay, it could be SQL, NoSQL, MongoDB, or whichever database you're using, right? So that is the DBMS part, right? So that software and handling of the entire thing is part of the database management system. Who will manage that? That is the part of DBMS. It is managing everything, the software, or how you can write the particular code, because Python does not understand SQL. See, Python is a separate language. Java is a separate programming language. SQL is a separate language. Okay, you write SQL inside a Java file or inside a Python file. Python or Java will say, what is this? I don't understand, right? What is this SQL you're writing? I don't understand. Okay, so for that, you have the entire DBMS, right? You have the entire DBMS that will help you, that will help Python understand that, okay, this is what the particular SQL query is meaning. So we go here, we get that data, and that is how you can read the data. All right, makes sense. So that is your entire database management system. So you have your database here. Encapsulating that DBMS is your encapsulate the database is your DBMS, which handles or gives you all the leverages to access this database. All right, and then you have the apps, right? You have the app or user or app, right, which accesses the database using this DBMS. Does it make sense? Does it make sense? Any questions? Let me see the live chat. Valentina says, every time I read API, I start crying. I never understood it, right? Okay, Valentina, right? Just remind me if towards the end of this lesson, if I have time, I'll tell you about that. But don't worry, we also have API testing, right? So don't worry, there's an separate entire lesson on API testing, okay, which will come very soon in a couple of weeks. So don't worry, right? You'll have a lot of things on API, okay? Jordan says API is the dude that takes your order to the kitchen and kitchen gives him to the right. Perfect, right, Jordan? That's a perfect example, right? That's a perfect example. I know that, right? Okay, okay. Well, you just say I have a whole lesson to cry, right? No, not exactly. Well, you'll see API is cool, right? API is very, very cool, right? It's not that difficult, right? If it, very short, if I just have to tell you in 1 minute, right? If in 1 minute I'll tell you, so like the login file that I was talking to you about, right? So there's a login.py or login file here, right? So you can think of that one file as an API. Okay, so let's say you want to get let's say the person has logged into amazon.com, and I want to display all the products, right? All the products that are there. Okay, so I will send a request to one file, right? So one particular route. Okay, that's for one particular route. That's the API, right? That's the endpoint. Okay, and that file is the endpoint. Now that file is the job of the API to go here, do whatever it wants to do, and get back to you the result. Okay, so if you're looking from the client perspective, the API is you just saying that I will send you the data, just give me the response back, right? For example, if I send you the username and password, just give me back whether it's correct or incorrect, right? Whether I should log in or whether I should invalidate the login, right? It's login successful or login unsuccessful, right? Unsuccessful. Okay, so yeah, that's the API, right? That's the API, one particular endpoint. Okay, what is happening behind the scenes, how it's done here, that's none of the business of the client. Okay, client is not responsible for that. It does not want to know, right? So those are what APIs are for, right? Just send in one particular thing and you'll get the response. Okay, that's in just 1 minute, right? Sorry, but you'll have an entire lesson on that. Okay, so don't worry. Okay, okay. Seraphim has given a wonderful details of the API, right? Great, thank you, Seraphim. All right, awesome. Okay, so let's move forward, right? Examples, right? So examples of systems with databases, right? So these are very common examples. For example, let's on e-commerce platforms. Okay, you have online stores like Amazon and eBay that use database to manage your inventories, right? So all the products and inventories that you see on these e-commerce website, right, they're stored in the database. Okay, the customer information, the orders that a particular customer has made, the payment processing, right, everything. For example, a social media network like Facebook, Twitter, Instagram, right, they use databases to store the user's profile, right? So if you have signed up for it, your profile is stored in the database. The post, the messages that you make, and the interactions that you do, everything is stored in the database. Okay, for banking systems, banks use the database to manage the customers' accounts, right? So if you're your bank will have your particular record in their database, right? What transactions you're making, everything is stored in the database. What loans you've taken or what financial records you have, everything is stored in the database. Okay. Similarly, in all other examples, right, you can read through all these examples that are there where you use database to store data, right? What are the advantages and disadvantages of database? So advantages is that reduce data redundancy, right? So you don't have redundant data, so you don't keep saving the data again and again. Okay, if you have a proper database management, right, you don't have redundancy. Reduced updating errors and increased consistency. Okay, why? Because see, if I was using my Excel or this Google sheet, right? For example, if I'm using this, okay, what might have happened, right? What might have happened is I could have, let's say I'm registering this, right? So I am registering, let's say a new person, 994, right? Let's say, and let's say person's name is Harshit, right? Okay. And I might give an ID, let's say 4, right? By mistake, thinking that 4 is an event, right? 4 is an event which is already here. Okay. So I might be thinking that, and by mistake, I have added this 4, right? And whereas 4 is no such event, right? No such event is existing over here. Okay. So this is possible here, right? It's possible to make these mistakes here, but in your relational database or SQL, right? That mistake is not possible. Why? Because SQL will not accept this value. It will simply not accept this value. It will say that there is no event with ID 4, right? So therefore it will not enter this record, right? So therefore it is consistent, right? So you have your consistency in place, okay? And it reduces your errors, okay? And you have more greater data integrity and independence from application programs. You have improved data access to users through the use of host and query languages because it's a centralized data. Now, multiple clients can use it and use the language to get the data, right? Improve data security. Why? Because if I have it just in an Excel file or in my Google Sheets, right, the security is not that much. Database, right? Because now you have dedicated companies who are providing you that service, right? So they have proper measures of security in place. Okay, then you have reduced data entry, storage, and retrieval cost, right? Your cost reduces, facilitate development of new application programs. What are the disadvantages? Absorbing significant increases in data volume, right? So yeah, when you have huge data volumes, that creates issues. Okay, ensuring data security, again, that's a disadvantage, right? You have to, if the company is not vigilant and they do not take the correct measures to secure the data, it's vulnerable to hacks, right? And sensitive data might get leaked, okay, which you don't want. Keeping up with the demand, right? Managing and maintaining database and the infrastructure, and removing limits on scalability, because you have some limits on scalability as well. If you have, let's say, huge set of records, right? Many people, let's say 1 million people have registered to your website. Okay, so your database, right? Uh, the limitations are there because it will not be fast. So if a new person is coming in trying to log in, right, or a person comes in and is trying to log in, the data has to scroll through all 1 million data, right, and see where is your particular username and what is your password. It has to check through a lot of records, right? So it creates issues with scalability. All right. Okay. Makes sense, right? Makes sense. Any questions, any doubts so far? Perfect. Awesome. Okay. So now I told you about DBMS, right? The entire stuff about DBMS and how it is managing your data. So you have the components, right? What are the components of the DBMS? See, you have the hardware, right? At the core is the hardware, right? That is actually where your data is residing, right? What is the hardware? The hardware could be the disk, right? The physical hard disks, or it could be RAMs, right? Anything, right? That's the hardware where your actual data is residing. Okay, then you have the software, right? So surrounding that is your software, right? You have the software, and then you have the data, the actual data. Okay, so if you look at this diagram, right? So this is the user, right? You have the hardware, you have the software surrounding it, you have the database access language, right? This is the data. So let's go in through one by one, right? One by one. So hardware is what? Hardware, it means the hard disk that I told you about, the input output channels for the data, and any other physical component that may be involved where the data is actually stored, right? So it could be a RAM, like I told you, it could be ROM, it could be hard disk, okay, anything, right? Anything which is actually physically storing the data. That's the hardware part. Okay, what is the software? Right, the software is more like the wrapper, right? It's like the wrapper around the physical database that I told you. Okay, now the software is what allows you to write the language, right? It allows you to write that piece of code which will then go and access the data or retrieve the data or work on the data. Okay, now the DBMS software is capable of understanding the database access language, right? So that is the database access language. For example, SQL, right? SQL is the database access language, the language which you write to access the data. Okay, so that is your database access language. Okay, then you have the data, right? The data is the core data, right? Whatever you want to store in the physical hardware, right? So that is your data, okay, that you want to store. Metadata is what? So you'll come across the term called metadata. Now, metadata is the data about the data. It's not actually the data, but the data which is describing the data that you're storing. For example, when you're storing some data in the, for example, when I store my name, right? If I'm storing my name in a database, the DBMS will store when the name was stored in the database, right? What exactly was the time that has stored this data? Okay, what is the size of that particular name, right? Like how many bytes am I using to save that name? Is it stored as related data to some other data, or is it independent? Okay, so these are the descriptions about that particular data, right? So the data about the data is known as metadata. Make sense? Then you have procedures, right? What are procedures? So procedures are general instructions, right? You have to have some guidelines and some instructions on how to set up, right? How to set up and install the DBMS. For example, let's say if I'm working on Postgres, right, or SQL or MySQL, right? So there are some steps, right? How do you install it? How do you make it working with your environment? And how do you connect to it, right? So all those guidelines, right? All those instructions are known as the procedures. Okay, how do you log in, log out of the DBMS? How do you manage the database? How do you take backups, generate reports, etc.? Okay, so all these are the instructions and those are the procedures, right? Then you have the database access language, right? So there has to be a particular language which will help you to create new database tables, insert the data, to fetch the stored data, to update, delete, and to just manage the data, right? So that is the access language, database access language. Right. Finally, you have the users, right? Users who are working on the database. So one is a database administrator who handles the data, manages the entire database, and takes care, right? The DBA takes care of the security of the DBMS, its availability, managing the license keys, and managing the accounts, and who has access to what. Okay, then you have the application programmer or the software developers, right? They're the group of users, or the software testers, right? They use the designing of the data, right? This group is involved in the developing and designing the parts of the DBMS, right? So the developers design the data. The testers are more involved in testing the entire database, right? Whether it's consistent, it's working as intended, what is the, let's say, the security of it, right? What is the, let's say, scalability, right? And what is the, how many concurrent users can the database handle? So all that. Okay. End users, right? These are the last user, end users. For example, the clients, right? The clients. So it's you are using in your mobile phone or in your laptop or wherever, right, in the web you're using. So that is the end user. Okay, all these put together is known as your DBMS. So now you can look at this diagram and understand you have the hardware at the core, right, where your actual data is residing. The hardware can be what? The hardware can be the hard disk, it could be the RAM, ROM, right, anything. Software is the software surrounding it, right, which will help you access or write the language, which will help you manage this data. Okay, then you have the actual data. These points that you see is the actual data that is being sent here, which will be stored in the hardware. Okay, you have the database access language. It's the language, for example, it's a MySQL, right, or any other language, MongoDB. Okay, so those are the languages which will help you in writing this data to the database, to this particular hardware, or retrieving data from there, whatever, right? And these procedures, right, the procedures are how you install and how you work around with this, and ultimately you have the end user. So this in nutshell is the components of a DBMS. Does it make sense, right? Does it make sense now? What is a DBMS, and what exactly is a database now? It's not just the data, right? A database is not just the data, but it's the data along with the DBMS. Entire thing put together is known as a database. Does that make sense? When it says end user these days, the modern applications, web or mobile store user data. Can you explain this? Sorry. Does it mean the end user is not a user, but an app, right? Exactly. Yes, Valentina, that is correct, right? So end user is actually uh, the client, right? It's the client. For example, in this that you see, right? So this is the client, right? This laptop is basically the end user. Okay. Now someone is a physical human is actually working on this laptop. That's the user, right? But this client is the user, right? This client is the user. Okay. So one and the same thing, right? Basically one and the same thing. Makes sense? Let me see. Let me look at the sentence. So the modern applications, right? So because see the end users are the, let's say if I'm using it on a laptop, right, and let's say I'm using amazon.com here on my laptop, right? So that's the browser, right? Now browser is the client. Okay, if I'm using it from my phone, right, I might have an application, right? So it's a web app. Okay, or a native app, right? So you have an app on your phone. Okay, or you can use a web app, right? So those are the different clients, right? I could be the same user, but those are the different clients, and those are actually taken as the users. Okay, does it make sense? Does it make sense, Valentina? Okay, I read user and it was misleading for me. I thought of a person, right? Yeah, yeah, Valentina, that comes across as that, right? Yeah, user. Okay, if you imagine that, let's say if the person using it from my mobile is a different person, and the person if I'm using it from my laptop is a different person, right? So I am Harshit A, Harshit B, right? If you imagine it like that, then yeah, then you can think of them as persons. Okay, but to remove that confusion, what they do is we think about it from the client perspective, right? So laptop is the client, or the browser, right? Not even laptop, the browser. Okay, because you can have multiple browsers, right? I can open amazon.com from Chrome, then I can open amazon.com from Safari in my same laptop, right? I can open amazon.com from, let's say, Mozilla Firefox, right? So those are three different clients then. Okay, so like that. Okay, Valentina is clear, right? Perfect. Awesome, awesome, awesome. All right, so let's move on, right? Let's move on. Yeah. So what are the types, right? So yeah, let's come to the types of databases now. Okay. So data can be broadly classified into four types. And so first you have structured data. This type of data follows predefined model, making it easy to store and process, retrieve and manage the data. For example, data in relational database. This is the kind of data that we'll be talking about more for SQL, right? SQL is basically structured query language, right? And so structured data, like this is a structured data that I showed you, right? This is structured, right? You have this table here, you have this table, right? There's a structure, right? There's a proper structure, tabular format. You have the rows, columns, and they are interconnected. This ID is connected with the IDs over here. It's interconnected. That you have a structure. Okay, so that is structured data. Okay. On the other hand, you can have unstructured data also, right? Tell me, how can you have an unstructured data, right? Give me an example of an unstructured data. So unlike structured data, unstructured data does not follow any specific model, right? Okay, the examples are given here, but tell me in the live chat, right? Tell me in the live chat if you can think of any examples of unstructured data. Think of any unstructured data, right? Any unstructured data. Ines PDF document, right? Okay, picture, right? Yes, okay, Ines, right? Yeah, you can think of that, right? Because ultimately, picture goes down into bytes, right? It has all those, right? Yeah, okay, correct. Okay. See what I'll tell you, right? See, for example, okay, like text, right? Text, video, audio, right? All these can be, right? Audio file can be unstructured, right? Note, unstructured is not completely without a structure. For instance, an audio file has an encoding structure and associated metadata. Okay, I'll tell you more about this, right? I'll give you one example of how you can have unstructured data. Let me just finish the slide. Okay, then you have dynamic data, right? Dynamic data refers to data that changes very frequently. And examples include like office documents and transactional entries in financial databases. Okay, so those are dynamic data which is changing very quickly. Static data is what? Static data includes, let's say, medical imaging data, MRI or CT scans, which will not change, right? It's there once, now it's there, right? It will not change. Static means it's just static. Okay, it's not going to change. Okay, dynamic on the other hand is which what changes frequently, right? Now let's look at relational versus non-relational database firstly. Okay, firstly, what is a relational database? Like I told you, store structured data in tables with rows and columns. Okay, that is your structured data. You have rows, columns, and tables, right? The one that I showed you in this Google sheet, right? So you have a table, you have another table, you have rows, columns, and that is your structure. Okay, and it is accessed using SQL, right? So that is a relational database. Okay, they ensure data integrity through asset properties. What are asset properties? We'll come to it in about in a couple of slides. So don't worry about that. Examples of the structured database, right? What kind of databases have the structure? So MySQL is an example. Okay, Postgres, right? It's known as Postgres because PostgreSQL. Okay, Oracle, right? These are the examples of your database, right? Which can help you in storing data in this tabular formats. Okay, best for applications needing structured data and complex relationships such as finance, inventory, and e-commerce. Okay, for example, if you look at this, right, if you look at this particular diagram, let me zoom into this. Okay, you look at this, right, you have this users. Okay, now see, one box is actually one particular table. Okay, one box is just one table. Okay, so like the table that I showed you here, right, this is one table. Okay, so one box that you see here is one particular table, and these things that you see inside this ID, first name, last name, email, these are columns. Imagine them as columns of the table. Okay, so we have a users table. It has the ID column, it has a first name column, it has a last name column, it has an email ID column. These are all columns. Okay, these are not rows. Okay, it's represented here as a box with rows, but imagine when you imagine the tabular format of the data. So users is the table. Okay, ID is the particular column, first name is the column, last name is a column, email is a column. Okay, and now this is connected to the, let's say, tags, right? So there's a tags. Okay, tags is a different table. It has the ID and it has tag, right? User ID is again linked over here, right? So this particular user ID will come here. Then you have a movies table, right? The ID of the movie is coming over here, right? And you have the name of the movie, you have the description. So all these are different tables, right? You have the ratings, right? Ratings of the movie. You have the ID, you have the rating. Which user, right? This particular user has given this rating for the particular movie. Okay, don't worry about how this is connected because these are joins that we'll be discussing more in the next lesson, right? On Tuesday or next week. Okay, so this is how the tables are connected. The point that I'm trying to make here is that you have these tables and they are all interconnected. So therefore they're related to each other. That is known as relational database. And each data is, or each table is stored in a tabular format in terms of rows and columns. Okay, so that is a relational database. Does it make sense? Does it make sense? What is a relational database? Give me a thumbs up, right? Is it clear what is a relational database? Because this is this very, very important relational database because we'll be working on SQL, right? And we'll do questions, practice questions, lab exercise, everything on SQL. Okay, and that's your relational database. Okay, so make sure this is absolutely clear. What is a relational database? Okay, if at the very if at the most simplistic example that I have to give you is this, right, that I showed you. So you have a table here. This is connected to this particular table, right? Both have the ID common. Okay, so it's connected, and tabular format, rows, columns. That is a relational data. Okay. All right. Okay. Now move to non-relational database, right? So something is known as NoSQL. Okay. NoSQL means what? It's a non-relational databases. Okay. So you have different types of database which are not related also, right? So you have non-relational database as well. Okay. They handle the unstructured or semi-structured data. These types include document-based or key value pairs, right? Key value pairs, white column stores, graph database. Okay. For example, MongoDB, right? Cassandra, Redis, Ideal. Now, earlier you had MySQL, Postgres, right? All those were examples of relational database. Here you have MongoDB, right? MongoDB is the type of database that helps you store in key value pairs. Okay, so there's no structure here, right? So key value pairs, right? I'll give you an example of this one. Okay, what is a key value pair? See how you can store key value pairs, right? What is key value pair? What happens is you store the data like this. You have a key. Okay, you have a key, and you give the value. Okay, you just give the value. Okay, and then comma. Okay, again you have the key, and you say colon, and this is the value. So here you don't have rows and columns, right? No rows, no columns, nothing here. You just give the key, you give the value, right? So key could be, let's say, the name, right? Name is what? Name is, let's say, Alex, right? Key is, let's say, event, right? Or I have this set up here, right? So let's look at this. Okay, the value is the corresponding. So you just have key value pairs. Okay, so for example, look at the event, first event, right? This first event that I had discussed this, right? So this one, this first row, right? If this first row and the people who have registered over here for event number one, right? Event A, okay? If I need to store that in key value pair format, right? So only key value pair. How will I store it? So I will do it like this, right? I'll say ID is what? ID is one. Okay, so this is the key, this is the value. Key is this, right? Name is the key. What is the value? The value is event A. Okay, date is the key, right? At which date is this particular event going to happen? On 4th September 2025, right? That's the value. Okay, key is the capacity. What is the capacity? 500. What are the registrations, right? Which people or who have registered for this, right? So inside registrations, again, you see I have this curly brace, right? This entire curly brace is again a set of record, right? It's a set of record. Again, it can have key value pairs. So inside this, again, I can have the, let's say, ID is 992, name is Alicia. Right, so Alicia has registered for this particular event. Okay, now if someone else comes in and registers for this event, I'll simply do a comma, right? Comma, and I'll say that, okay, ID is for the person, ID is, let's say, 993, right? And name is, let's say, Harshit. Okay. So again, you see key value, right? So these are the key value pairs. This is the key, this is the value. This is the key, this is the value. Okay. So here we are storing it in key value format. Now there's no structure here means that I can store this, right? See this date and capacity, right? This date capacity I can store here also, right? I can have it here also. So there is no structure, right? Anything can come up, anything can come down. It's the same thing, does not matter, because we are storing everything in key value pair. Okay, if you query this database and if you ask for the date, it will still give you 4th September. Even if this was on the top or the first or last, it will still give you 4th September because we're storing it in key value format. Okay, you ask for the capacity, it'll give you 500 value. If you ask for the registrations, it will give you this entire record that these are the registrations. Okay, so the advantage here is you can keep adding, right? So tomorrow you can keep adding. Let's say here, right? If you want to add in a new column, right? We want to add in a new column. Let's say venue address, right? I want to add a column of venue address. Okay, what is the address? Okay, now I cannot do that, right? So imagine if I have previous 1,000 records, right? If I already have 1,000 records already stored in my database, and now I'm adding a new column, right? I'm trying to add a new column called venue address. Okay, what will be the value here for those 1,000 rows? For those 1,000 rows that already have data, this will be blank, right? This will be blank, and that is not a good way to store the data. Okay, but here that problem will not come, right? Here that problem will not come. Why? Because I can simply do comma, right? I can simply do comma, and I can add it, right? I can add, let's say, venue address. Okay, venue address. Okay, and I can add the address. Okay, I can add the address over here. Okay, so that is a key value pair. This is how you store data in a non-structured format or in key value pairs, and that is NoSQL. So this was the basic of MongoDB, right? How MongoDB Cassandra is storing data in key value pairs, right? So apart from that, see, other database that you have is Graph, right? GraphQL is also a very popular way of storing data and very widely used in social media networks, right? So social media platforms that you see, if you want to connect, let's say you have friends, right? If you're using Facebook, you add people as friends, right? And how to keep record of who has added who has friend, right? So for that, graph, right? Graph databases are very widely used. Okay, for example here, right? Look at this. I'll give you a quick image view of how graph works, right? So let's say this is Matt, right? Matt has made some post, right, on, let's say, Facebook or Twitter. Matt has made post 1, post 2, post 3. Now Matt is friends with, right? Matt is friends with Sarah. Okay, Sarah is friends with Katie, right? Sarah is friends with Sid. Okay, Matt is friends with Tom, right? Tom is friends with Clay. Okay, Clay has made this particular post, right? Tom has liked this particular post. Okay, Sid has made this post, right? So like this, right? That is graph. Okay, that is how the database for graph is stored, right? So those are non-SQL, right? So there you don't have any structured query, right? You don't have any tabular format, right? No rows, no column. There's no structure, right? If you can look at from this image, right? You see any structure? There's no structure, right? Tomorrow Matt can make another friend. You'll have another circle over there. Sarah can have another friend circle over there, right? So there's no structure here. Okay, so that is non-structural, no SQL database. Okay, so relational database, right? It's the best for structured data with relational queries, and it ensures integrity with asset compliance. Non-relational database does what? It's optimal for unstructured or semi-structured data. It offers horizontal scalability and flexible data modeling. Okay. In summary, we should use relational database for structured data and relational queries, non-relational database for unstructured data, scalability, and flexible schema requirements. Okay. Other types of database that you have, right? You have in-memory database. For example, Redis, okay, a memcached. Now, what is this in memory? In memory actually means RAM, right? So in your computer or in your machines, right, laptop or physical devices, right? You know, there's something known as RAM. Okay, you have one thing known as hard disk, and another thing known as RAM. Okay, RAM is your random access memory, right? It is very fast to get data from there, right? So Redis is one such provider, right, that provides you, it's a database format that you can store in RAM. Okay, it provides you RAM, so therefore it is very fast. And this is used generally for, let's say, you want to do, let's say, direct chat, right? Direct chat messaging in, let's say, you're using Instagram, right? You have direct messages in Instagram, or let's say notification systems, right? You have a notifications. So for all those, Redis is used. Okay, it's very fast, right? Very fast. You cannot have, let's say, if someone has liked your post and you don't want the post to first go to the database, and then from the database it comes back to you and showing that, okay, person A has liked your post, right? That is very slow. Okay, Redis is much fast, right? Because it is storing in RAM. Okay, the data here stored is RAM. Okay, don't worry much about it, right, if you don't understand that part. But these are different types, right? You have these types of databases, and don't have to delve deeper into them. Okay, you have object oriented databases also, right? For example, this is an object oriented database. You have the object. It's very similar to like I showed you, right? The key value pairs. Okay, so you have the date, right? This is the instance of the object. You have this particular date, the activity code is this, you have the route number, right? You have the daily production, equipment hours, labor hours, and then you can have the this activity code, right? This is connected here, right? So with another object, right? You have another object. This activity code is connected here with the name, production unit, average daily production rate. All right, so that is object oriented also. Graph, like I told you about, right? That is a graph database. And you have time series, right? Time series is optimized for storing and querying time stamped or time series data, right? If you have time series data, it is helpful for that. Commonly used in IoT, right? IoT is information of things, or financial data analysis. Let's say stock market, right? Stock market has some time series data, right? Every day or every second the stock is the prices are going up and down. Okay, so for that you have these databases. Okay, examples are InfluxDB or Timescale DB. All right. Okay, let's look at a quick question, right? Which of the following best describes a characteristic feature of no SQL database? They exclusively use SQL for querying database data, or they are primarily designed for highly structured data, They offer flexible schema designs to accommodate varying data types and structures, or they are mainly suited for transactional data processing. Which of these do you think is the correct one? Okay, Seraphim has shared a great image, right? Thank you, Seraphim. That's wonderful. Okay, Theodora says C, right? Susan says C, right? Flexible schema. Binu says 3, right? That is correct, right? Absolutely correct, right? Absolutely correct. Flexibility, right? You want to flexible, you want a flexible schema, right? That's where no SQL comes into the picture, right? Perfect. Awesome. Awesome. All right. Okay. So database web-based system, right? So this is the system, right, that we talked about. Okay, you have the client or you have the machine here. You send a request, right? You send a request, and here is your application server, right? This is the server where the code is residing, right? In this code or in this piece of files is where you write your SQL code, right? We'll write SQL codes, right? We'll look in the lab exercises. So you see that is written over here, right? So there are pieces of files here. That's the server. Okay, that is where SQL code is written. Now that SQL query, right, that goes to the database, right? That goes to the database, fetches the data that you want, and gives you back the result over here. Now what you want to do with the result, that logic you can write here, right? So you have backend languages like Python or Java, whatever is the language that you're using in your server over here. Then you can manipulate, right? Once you've got the data from the database, you can manipulate and then send back the response however you want. So logical part, all that is done over here, right? So this is the client, right? The client is serving as the user interface, facilitates user interactions with the application. This is what we talked about, right? The entire system, right? The entire system is the same. The web-based system, the user makes the request through the internet, and the request goes, you make the SQL query, you get the result back, you send back the response to the browser, right? The same, there's the same diagram. All right. Okay. Let's move forward, right? Asset model, right? Asset model and asset properties. Okay, so now for relational database, asset properties is very, very important. Okay, what is asset? They're the acronyms, right? Atomicity, consistency, isolation, and durability. So these are the four important points that makes the asset model. Okay, what are these, right? What are these? What is the meaning of atomicity? So database transactions must be atomic. That is, they must be an all or nothing, right? If any part of the transaction fails, the entire transaction must be rolled back as if it never occurred. Okay, so let's say you have a complex SQL query, right? You're trying to update some data. So let's say here in my particular table, I'm trying to update the name of the event and the date of the event. Okay, I'm trying to update both of those. Okay, so it should not be that the name has been updated, the date was not updated, right? That is not acceptable. Okay, either both of them will be updated or we roll back. If some error occurs after updating the name, some error has occurred, then roll back to the previous version and leave the name also as it is. Okay, that is the meaning of atomicity. Okay, consistency, all transactions must begin operating in an environment that is consistent with all the database rules. Okay, for example, all records have a unique primary key. When the transaction is complete, the database must again be consistent with the rules, regardless of whether those rules were violated during the processing of the transaction itself. So consistency has to be there. Like I told you, right? If this particular column, ID column, is connected with this particular event ID column, right? If both are connected, that consistency has to be there. So therefore, you cannot add 4 over here, right? This 4 is not acceptable. So therefore, you have consistency. Okay, isolation, right? Isolation means what? The isolation principle requires that transactions operate separately from each other. So let's say if I am updating the database to a particular name, and my, let's say, teammate, right? My teammate is also trying to update the same record, right? For example, we both are updating the particular name of this event, right? We're trying to update this name of the event. I am also doing it. My teammate is also doing it, right? So it should not be that I have updated this, then the person, it has to be isolation, right? My transaction will be in isolation with his transaction. So my transaction will be done first, then his transaction, or his transaction will be done first, then my transaction. Okay, so that there's no incorrect data, right? Because let's say if we want to change in some values, he also should see the changed value. It should not be that I have changed the value and he's not seeing it, and then he updates it to something else. Okay, so to avoid that, everything is done in isolation. If a database receives two SQL transactions that modify the same data, one transaction must be completed entirely before the second transaction is allowed to modify that same data. So that's in isolation. First one is done in isolation. Then once it's done, then the next one comes in. Okay, so this prevents one transaction from working with invalid data generated as an intermediate step by another transaction. So someone else is doing it, and some intermediate step is done, right? And you don't want that invalid data. Okay. Lastly is the durability, right? Database transactions must be durable. That is, once they are committed to the database, once the updation has been done, or once you've inserted the data, right, it has to be durable. What does that mean? That you ensure the durability through backup mechanisms. Okay. You have transaction logs and backup mechanisms are there which make your entire database durable. Okay. You don't have to worry about how the durability is implemented, because the companies that, let's say AWS, right, they're providing the services, they'll handle it, right? They'll handle the durability. Okay. They'll handle the backup mechanisms and the transaction logs, right? They handle all of that. But the point is that it has to be all this, right? Asset, atomicity, consistency, isolation, and durability. These 4 points are required in a DBMS. Okay. In your relational database, right? So that's the asset properties. All right. Makes sense, right? Makes sense. Any questions? Any questions? And we'll go for a quick 10-minute break. Valentina says, for your example on isolation, which error would one of the two operators see? I mean, as one can't modify the same column, will they modify and then saving it will go back to previous information? No, no, Valentina, no, no, no. There will not occur until unless mine is completed. Okay. So once my event is updated, right? If I've updated to, let's say, event Y, okay. Once this has been completed, then there will start, right? Their query will start after that. And if they want to update to, let's say, event, let's say G, right? Then their query is executed after that, right? So it's an isolation. Make sense, Valentina? So will they see an error? No, 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 Valentina, they'll not see an error, right? See, because all the queries, see, there can be 100 queries in the queue, right? So like, let's say my query is here, right? My query is here, right? So query one, okay? There's query two, okay? There's query two. After that, you have query three, okay? Multiple people are writing the queries, right? So it's all in a queue, right? So one by one it will be executed. The first one is executed. Let's say my query one first execution is to change this to event Y, right? Now this is done, right? Once this is done, then only this one will be executed. They're all stored in a queue, right? So the server has it lined up, right? Everything is lined up. Then the next query will be executed. Okay, let's update this to G, right? Then the next query will be there, right? Next query is, let's say, updating the capacity to 500. Then this will be updated. Okay. Then the next query is executed. So everything happens one by one, right? One by one sequentially. Okay. Right, I was thinking of two people changing at the same time, right? Yeah, so same time they have sent the queries same time, right? So they have sent the queries at the same time to the server, but the server will make a record, right? So like who came the fraction of the millisecond first, right? That will come first. Okay, then the second one, right? So it will be in queue. So it happens sequentially, right? The server will not allow both of them to simultaneously crash, right? Okay. It is Excel's fault, right? Yeah. Okay. Okay. So that is it, right? We'll stop here for a quick 10-minute break and then resume after that. All right. Okay. Raya, back.
Please feel free to take it away.
Thank you, Raya. And congratulations to whoever chose three, right? I chose 13, right? So almost there, halfway there, right? Next time. Okay. Okay. So, all right. Glad that you all had a break. Okay. So let's come back to where we left off with. Quickly give me a thumbs up if you can see my screen. Perfect, right? Okay, Binu says I got a question, right? In terms of atomicity in DB, I would like to mention a real case scenario. Like if we are booking flight ticket and the booking fee deducted from the bank account, and but the booking wasn't successful. Why is that? Just got curious. So you're booking a flight ticket, right? And the booking fee is deducted from the bank account, but the booking wasn't successful, right? So great question, right? Binu, that's a great question. So what happens is, see, your banking, right? See, the banking system is different, and the flight service provider, right? So let's say it's the website, okay? The website which is doing your booking, right? The flight booking which you're doing is separate, right? So both are separate entities. Okay. So here is when you book for a ticket here, right? So let's say you've picked a particular ticket for a particular flight, right? And you go to the payment page, right? When you go to the payment page, then what happens is this website is actually giving all that handling of the payment part to a third party provider, right? That third party provider is the payment gateway. Okay, that's the payment gateway. Okay, so your website is actually using the payment gateway to make the payments, right? Now the payment gateway might have some issues, right? This payment gateway will accept your credit card details or whatever payment method you want to choose, and the payment has gone through, right? So this guy has said that okay, payment is done, right? Deducted from your bank, because this payment gateway will interact with your bank and see if the particular credit card is valid and details are valid. It'll deduct your amount, right? Once that is done, this payment gateway will send a message back to the website that hey, I received the payment was done correctly. Okay, then the website will then actually book the ticket and store it in its database that yeah, the ticket has been booked. Okay, now if there is some mistake or some issue between the communication between these two, right, the website and the provider, right, if there's some issue between them, then it might fail. Right, so the payment has gone through over here, but the payment gateway didn't give the confirmation back to the website, right? So for some reason, let's say uh, some bug, right? Or maybe some issue has happened because of which the payment gateway didn't give the correct response back to the website. So website will say it's failed, right? Your booking was not done. And because the booking was not done, then you can reverse the payment also, right? Does it make sense, right? Does it make sense in short, Bino? Because they're separate entities, right? The payment provider is separate, the payment gateway is separate, and the website through which you are booking the flight ticket is separate, right? They interact between each other using APIs, right? So this will send an API request here, this will send a response here, right? So they are interacting between each other, but that communication, right? Somewhere in that communication, some mistake might be there. Okay, and that is what causes the issue, right? When it is, it's a bug, right? Yeah, great, awesome. All right, okay, so let's move forward, right? Let's move forward to SQL, right? Now we'll focus on SQL operations and how you actually write the code to get the data, fetch the data, manipulate the data. Okay, so before that small introduction to SQL, right? SQL is what? It's a structured query language. Okay, so from this very statement, you can see, right? Structured query language. So it is a language to query structured data. Okay, it's a standard programming language used for managing and manipulating relational databases. Okay, so SQL works on relational databases only. Okay, originally it was developed by IBM in the 1970s. SQL has become the de facto standard for interacting with relational database management systems. Okay, SQL provides a comprehensive set of commands for performing various operations on databases. Now, broadly, there are three types, right? Broadly, there are three types that you can do. One is DDL, right? DDL is the data definition language. What does that mean? First, you need to define the data, right? So before you can manipulate the data or you can read through the data, you need to define the data. What does that mean? That you have to create the tables first, right? You have to create the table, okay? Alter means to change the table, and drop is to delete the table. Okay, so first you need to create, for example, here, right? This one that I showed you. First, I created this table, then only I can read the data from here, right? Or I can insert a record here, right? So I can insert a new record here only if I create this table. If I don't have this table, I cannot do anything, right? So first I have to create a table, a blank table. That means only with the columns, this ID, name, date, capacity, right? Only this blank columns. Okay, so that has to be created first. So that is your data definition language. Okay, so you can create the table, you can alter the table, or you can drop the table. Drop means deleting the table. Okay, then the second part is the data manipulation language, right? This is DML. Okay, so once your table is created, what do? Now you can add records, right? You can manipulate the table. Manipulating means what? You can insert records into the table, you can update the records, right? You can retrieve the records. Select means you can retrieve the data, okay, or you can delete, right? You can delete some record. Okay, that is the data manipulation language. All right, then you have the data control language. Control language is to control access to the data within the database. So within the database, you can say that which user, right, you want to grant some or you want to revoke access, right? So you can have different users with different privileges. Okay, so let's say some user has a privilege to only read the data, right? They can only fetch the data, they cannot modify it, right? They cannot update, they cannot delete, or they cannot change anything. They can only read, right? And maybe there's some user who can manipulate, right? They can update but they cannot delete. Okay, so those are different access, right? Access controls, and that is under data control language. All right, so SQL is a versatile language that is supported by most relational database management systems, including Postgres, MySQL, SQLite, Oracle, SQL Server, and others, right? It is widely used by developers, database administrators, and data analysts for tasks such as data retrieval, manipulation, and data administration and reporting. Okay, it's a very, very popular used language, SQL and SQL, right? You can call it SQL also, SQL also, right? SQL used to be the earlier name, but SQL is the full form is structured query language. All right. Okay. Now we'll actually write a particular query, and let's actually see how you write a query, how you can get data. And this part that you see here, right? This is a terminal that you'll see in your Codio, and the database is already set up here, right? The data is already connected, and Codio has taken part of all that, right? Taken care of all that for you. So don't worry. Here, all you have to do is write your queries. Okay, so you need to write your queries over here. Okay, so first we'll see the data, right? So an actor table, right? See, actor table is already created. So Codia has already created a table called actor. Okay, so if you look here, right? So the table called actor has already been created, which has the data about actors. Okay, now I want to access the data here, and I want to see, right? I want to access the data, and I want to see what is inside this table. Okay, because right now you see we cannot see anything, right? It's a blank screen. Okay, you cannot see anything. Okay, now if you want to see what is the data here, see the first and foremost thing is to use a select clause. Okay, what is the select clause? Now select clause is this basically works on columns, right? Which columns of this actor table do you want to see? Okay, that is what you say in select. Okay, so if I say select, right? If I say select, let's say name, right? Select name, comma, let's say age, right? That means what? I want the name column and age column from which table? From this actor table. Okay, from the actor table, I want the name column, I want the age column. Okay, now you need to say, right? From, right? From which table? From actor table. Okay, from the actor table. So I say select, right? Select is working on what? Select is working on the columns, right? Only works on columns. So which columns do you want? I want the name column, I want the age column. From which table? From the actor table. Why do you need this from part? Because see, in your database, right? In your database, you can have multiple tables. Like here, right? If this is my database, I have this table called events. I have this table called registrations, right? I can have 10 such tables. Okay. So you can have 10 tables. Okay. Now in your SQL query, right? In your SQL query, you need to say that I want to select the column name and age from which table? From the actor table. And at the last, you give a semicolon to say that that is the end of my sentence. Okay, and once you press enter, right, then you'll fetch uh, the, this is the SQL query, right? This is the SQL query. This is how you write the SQL query. Okay, and the SQL clauses you put as capital, right? Like select, right? Select is the clause, so you keep this as capital. Okay, this from will be capital. Okay, it's not necessary. It's not necessary. It's not case sensitive. So even if you write it in small, like select, it also works, right? It also works. But the convention, right? Convention is to keep it as capital. Okay, so you keep it as capital, right? Now, the thing is, if I say select star, right? What is the meaning of the select star? Can anyone tell me in the live chat, what is the meaning of select star? If I say select star, what is the meaning of this, right? I select star from actor. Okay, what is the meaning of this? Select star. Valentina says all, Binu says all, Ina says all all what? Maybe says all the fields in the table. Maybe all the fields in the sense, what are fields? That's correct, right? Maybe that is correct. Okay. See, all what, right? See, all is correct, right? See, star means all, right? All, but all what? All what? See, select is working on what? I told you again and again, right? Keep this very, very, very clear in your mind, right? That select is working on what? What does select work on? Binu says all the data for the table, right? No, Binu. See, that is the distinction, right? That is the difference that you need to be clear with, right? Select does not work on the entire data, right? Select is only working. See, if you look at this here, right? It's only working on these columns. It's not working on the entire data, right? Because see, how is this data made? It's made with columns and rows, right? Columns and rows put together. Okay. So if you want a subset of this, right? If you want a subset of this, let's say I just want this. Like if I want the subset, right? So then you need to say, right? Then you need to tell the computer which columns and which rows do you want. So any subset from this entire table can be retrieved by telling which columns you want and which rows. If I say I want, let's say these two columns and let's say this two row, right? So I can highlight this, right? Name and event ID column and row number 3 and row number 4, right? So then my highlighted part will be given back to me as the response. Okay. So any subset that I want of this data, I only need to tell I need these columns and these rows, right? If I tell the computer in my SQL query that I want these columns and these rows, it will give me the perfect subset of the data. Okay. So all you need to provide is which columns you want, which rows you want. Okay. And in that, be careful that select is only working on the columns. Which columns you're talking about, select is only working on them. Okay, not on the rows, right? We'll discuss about the rows later on, but select is not working on the rows. Okay, select is working on only columns, right? So if I say select name and age, so only these two columns. If I say select star, right? Select star means what? Select all the columns that you can see. All the columns that you can see here, select all of those.
I think Harshit froze. I'm not sure. Seraphim, can you? Okay, just a second.
Yes, I think he froze.
That, right? Okay. Last part was audible, right? What was last part audible?
Yes, it was, but then like you froze for like, so maybe you can just like go over the last point you were discussing.
Perfect. Awesome. Right. Awesome. Okay. So what I was saying was, see the select, right? The select part is working on the columns only, right? Not on the rows. Select works only on the column. So when I say select name comma age, so it's working on these two columns. So I'm saying that choose these two columns from the entire table. Okay. Select star means what? Choose all the columns, right? Take all the columns. I'm not talking about the rows over here, right? I'm not talking about the rows here. Okay. So don't put the rows here in your mind, right? This is only working on the columns. Okay. And then I say from the table, right? From which table? From the actor table. Okay. So I say select star from actor, right? Now, is that clear, right? Is that clear? Is that clear? Absolutely clear. Select is working on what? Valentina says, okay, so all columns, but with limit 10 rows, right? 10 limited rows, right? Correct, Valentina, that is correct, right? That is correct. I'm coming to the second part, right? I'm coming to that part, but yes, right? So select is working on your columns, right? Now, what works on the rows, right? What works on the rows? Okay, so what works on your rows is the where clause, right? So where clause is another clause which works on your rows. So if I say select star from actor, right? Right? Where let's say name is equal to, I say John. Okay, I say John. Okay, so this part, right? This part is working on the rows. So this is saying which rows do you want? This is saying which columns you want. So here, what is highlighted? All these columns are selected, right? All the columns is got, right? Now this one is saying which rows do you want, right? Which rows? This part where name equal to John is saying which rows you want. So if there is, let's say, if I have an actor table, right? Imagine this as the actor table, okay? And this particular row, right? This particular row has John, right? John is what I said, right? Yeah. Okay. So this part, right? So this row will be selected, only this row. And which columns? All the columns. So what is highlighted will be returned back to you. Okay. Because only this row is selected. That is due to the where clause. So where clause is working on which rows do you want, right? Select clause is working on the columns. Okay. Here, if I say only the name, right? If I say select name from actor where name is equal to John, right? And if this is your actor table, then only this part will be given to you. Why? Only this part, this cell will be given to you. Why? Because the columns I've set is name column only, and which row? Only this row. So only this row, and out of this row also only this column, right? B column. So only this value will be given to me. Okay. If I say, let's say, select name comma event ID, right? Event ID. Okay, from actor table where name is John, right? So now this gives me these two. It will give me these two. Why? Because I'm saying select the name column, event ID column, both of these columns. Okay, and in the where clause, I'm saying only that row which has the name equal to John. So only that row. Okay, if you have multiple rows, right? If you have multiple rows, this was also John, right? If you have multiple rows with the name John, then that will also be selected. This is selected and this is selected. Okay, so in the output, what will you get? In the output, you'll get something like this: John 2, right? And you'll get John 4, right? This is what we'll get in the output. Okay, John 2, John 4, right? Why? Because this is John 2, this row is selected and this row is selected. And which columns? Only the name column and event ID column. Okay, only those two columns are selected. Okay, so if I do a star, right? If I do a star, that means what? Star will give me all the columns, right? All the columns. And if I don't put in the where clause, right? If I miss out on the where clause and I remove the where clause, that means by default, it will give me all the rows. Right, so by default, if I don't have a where clause, it is by default meaning that give me all the rows that are there. So if I do the select star from actor, then give me all the columns because of the star. And by default, because the where clause is not there, right? Because that where clause is not there, you will get all the rows, right? Whatever rows are there, you will get all the rows. Does it make sense? Does it make sense? Valentia says only rows with name John, right? That is correct, right? That is correct. Okay. So where clause is working on your rows. Okay. Select clause is working on your columns. Does it make sense? Is it clear? Give me a thumbs up, right? Give me a thumbs up if it is clear. Ina says makes sense, right? Because this distinction should be absolutely clear, right? Select only works on the columns. Where clause is what works on your rows. Okay, if you know this, then you can get any subset of the data. You can get any subset of the data. Why? Because you know which part is working on the columns, which part is working on the rows, and how to get what. All right. So now let's take an example, right? Select star from actor. Now we'll use a clause called limit also, right? Limit 10 says what? That okay, you might get all the rows, but in the display, in the output display, only show me the first 10 rows, right? Limit 10 means what? Only show me the first 10 rows in the output. Why do we need that? Uh, because here we need is there are thousands of rows, right? There are thousands of rows, and this will fill up, right? It'll keep going, it'll keep going. So you don't you'll not be able to stop to see that, right? So what you want to do is you want to just see the first 10 rows, right? I just want to see get a glimpse of what my data is, right? I'm trying to inspect the particular table. Okay, so what I can write over here, right? So let's inspect this particular table, right? So what we can say is we can say select, right? Select star from which table? From the actor table, right? And I want a limit of 10. Okay, why do I want a limit of 10? Because there are a lot of rows, right? There are a lot of rows and this will fill up, right? I don't want that. Okay, so this is select star from actor limit 10, right? I press enter and there you see, right? This is your data. Okay, so your actor ID, right? You have a column called actor ID, you have a column called first name, you have a column called last name, you have a column called last update. Okay, and it has given you only the 10 rows, right? Only the first 10 rows. Why? Because of the limit 10. If I don't use this limit 10, then it'll give me all the rows. Okay, and if you want only some subset of the row, right? If you want only the subset of the row, then you use the where clause. We'll come to the where clause, but that is for the subset. All right, so this is the select, right? So we are on the select part, right? Select part. Okay, so select is working on your columns. So now see, if I say select, right? If I say select, let's say first name, right? First underscore name. Okay, from which table? From the actor table, right? From the actor table. And again, I say limit, let's say 2, right? I just want to see the first 2 rows. Okay, so now what happens? I'm only choosing the first name, right? Only this column, right? I'm only choosing the first name column. If I press enter, you see I only get the first name column. Why? Because in my select clause I have shown only the first name. Okay, if you want multiple, right, you can say select, let's say first name, and you can have, let's say, comma, right? You want first name, and I want, let's say, last name also, right? Last underscore name. Okay, so I want these two, right? So select first name, last name. That means these 2 columns from the actor table, right? Now, because there's no where clause over here, right? I've not added any where clause, so therefore it will give me all the rows, right? But I'm saying limit, right? So just show me the first 2 rows. The query will get fetch all the rows from the database, but in the output is just showing you the first 2 rows. Okay, so now you see you get only the first 2 rows and the first name and last name column. Okay, so that is how you write a basic SQL query, right? That's how you write a basic SQL query with the select clause. All right, now we have some CRUD operations, right? What are CRUD operations? CRUD operations are basically create, read, update, and delete, right? So these are the 4 most elementary stuff that you need to do in any database, right? You need to create, you need to read the data, you need to update the data, you need to delete the data. Okay, so first let's look at the create part. Right. See, in the previous example, the actor table was already created for you, right? It was already created, the database already there. And so you could have read the data, right? But now we need to create, right? We'll create a table. Okay. So let's create a table called countries. So if you look at this, right, this is how you write the particular query, right? You say create table countries. Okay. And in the bracket, right? See, I'll show it to you here, right? In a more better format, right? Okay, so see, what you do is you say create table, right? So create table, this is your SQL query, right? You're writing create table. Okay, then you need to give the name of the table, right? What name do you want to give to the table? So I'm saying create a table called countries, right? Call the table countries. Okay, now inside that, right, then you have this bracket opening here, this bracket closing here, right? So what is there inside that table? So I have columns, right? I have columns. So I'll say the first column is country underscore ID, right? Country underscore ID is the first column, and it has to be serial, right? It is the primary key. Okay, it's the serial primary key because it's in sequential order, right? It's the country ID. Okay, the second column that I want is the country name, right? So that is the second column that I want is the country name, and this is the data type, right? This is the data type. Varchar means what? Variable characters, right? So it can have variable characters, can have 100 characters, right? Up to 100 characters. It's varchar, right? Variable characters. And I'm saying it is not null, right? Not null means what? That this column, right? This column cannot be left null. Whenever you are entering a data in this particular table, you cannot leave this column. Is capital city, right? I create a column called capital city. Again, it's varchar, right? 100 varchar. This is the type, right? It's a data type. For data type means what? That in this particular column, right? In this particular column, what kind of data, what type of data can I store? Can I store numeric value here? Can I store characters over here, right? Variable characters. What data I can store in this column? Okay, so that is what you're telling here, right? That is what you're saying here. Because remember, you're doing DDL, right? You're defining, right? You're defining right now. You're creating the table, you're defining the language. So you're saying capital city is the column. The data here will be stored as varchar, right? Which is having 100 characters and it is not null. So therefore, this column cannot be kept as null. Okay, then the official language, right? This is the column official language. Again, varchar, right? 100. And here you don't have this not null, right? We're not providing it as not null. That means what? That this can be left null also. That means we can have a blank value here also. The country name cannot be blank. The capital city cannot be blank. Okay, but this official language can be kept blank. Mind you, these are all your columns, right? So imagine them as columns, right? Country ID is the first column, country name is the second column, capital city is the third column, official language is the fourth column, right? So like this, you have these four columns. You're creating this table. The syntax is what? Look at the syntax again. Create table, then you have this brackets, right? Round brackets. And inside this, you say columns, right? You say column one, right? How do you want the column to be? Then column two, how do you want the column to be? The data type and etc. Column three, how do you want the column to be? So this is the structure, right? This is the syntax. And this is how you write the query. Create table. I want the table to be called countries. And these are the columns that I want inside this. All right. Makes sense, right? Makes sense. The syntax should be here, right? Yeah. So this is the syntax. So create table and the table name. And inside this bracket, you have column one. What is the data type of the column? Any constraints that you want to add, right? Column two, what is the data type of the column? Any constraints that you want to add, right? So this is what we'll do, right? Let me just copy this here and let's create this particular table. Okay, so you can see create table countries that we just discussed with four particular columns, and just press enter. Okay, so it says table has been created, right? Create table has been done. This is executed. How can you check it, right? How can you check if I want to check whether this particular table was created or not, whether it's correctly done or not? Valentina says it's 100 maximum length permitted in this case. No, Valentina. Yeah, I see Seraphim has answered, right? Great. Yeah, it can be more than 100, right? Can be more than 100. Don't worry, right? But you have to have some limit, right? Otherwise, anyone entering. So these are the constraints, right? These are the constraints, and that's why your data integrity stays in place, right? Because you can limit these factors. So it will not accept anything apart from that. So then say select staff from countries, right? Absolutely correct, right? Susan, that is absolutely correct, right? You can create a simple query, select staff from countries, which they have already provided you here, right? And you can see, right? So this should return you something, okay? And it says that we get 0 rows, right? So because there's nothing entered here, but it is giving you the columns, right? So that means the table is existing now, right? The table exists now and it has 0 rows, right? Because we've not inserted any data. Okay, so that is your create, right? So we've done the create. And now let's insert some values, right? Insert some values. How do you insert values? Again, look at the syntax, right? Look at the syntax. How the insert value syntax works is like this. Okay, So you say insert into, right? Insert into the table name. Say insert into this particular table name, that is the countries table. Okay. And then you say which columns, right? So you say insert into, so I'll show you here. You say insert into, right? So let's say table name, okay, and then you have the first brackets, right? First set of brackets. In this first set of brackets, what you say is you provide the names of the column, right? Column name, okay, column name, column name, right? So you provide all the column names that you want, right? And then you say the values, right? Values, okay. Here is, let's say, value 1, value 2, right? Value 2, using 2 columns. Okay. What happens is this value, right? Value 1 goes into this column first, right? Column name, right? This, let's say, column 1. Okay, so value 1 goes into column 1, value 2 goes into column 2. Okay, this value 2 will go into column 2. So it's corresponding, right? So you say insert into this particular table in these columns, right? Inside this table also, which columns do you want to insert the values into? Column 1 and column 2. So which values? Value 1 and value 2. So for example, look at this, right? Insert countries. I want to insert data into the countries table that we just created, right? And inside the table, right? Inside the table, which columns do I want to add the data to? I want to add the data to these columns: the country name, the capital city, and the official language. Only in these 3 columns I want to add the data. Now what are the values that you want to add? Now you say values, and this is where your second set of bracket comes in, right? What are the values? Spain, right? Spain will go where? In the country name. Okay, Madrid will go where? It will go in the capital city. Spanish will go where? In the official language, right? So this is how it goes. Spain goes here, Madrid goes to the second one, Spanish goes in the third one, right? So it's the first column, second column, third column. Does it make sense? So syntax is what? Syntax is insert into the table name, okay? And the bracket, you have column 1, column 2, column 3, so on. And then you say values. Value 1 will go in the column 1, value 2 will go in column 2, value 3 goes into column 3, so on and so forth. Does it make sense? Does it make sense? Let's quickly insert this value and see, right? Is that clear, right? So insert 0, 1, right? That means this has been inserted. Is that clear? Is that clear? Any questions? Let me see. Valentina says, so you can write table name or table name or table name and it will understand where to write the command. Valentina, so you can write table name or table name or table name. No, so it has to come here, right? It has to come here, right? This is just a placeholder, right? This is just a placeholder. Here is where your actual name of the table has to go, right? If it is actors, then actor has to go here, right? Insert into this particular table. Okay, so insert into, then the table name has to come here, right? Like here, this is the actual query. Insert into countries, right? This countries is the name of the table which we had created here, right? If you see, we had created this create table countries, right? We created the countries table, okay, which had this 4 particular columns, but no data has been inserted there. So we're trying to insert over there, right? So we say insert into which table? The countries table, okay? And inside the countries table also, which columns? These columns: country name, capital city, official language. And then what values inside that? These values: Spain, Madrid, and Spanish correspondingly in these columns. Make sense? Make sense, Valentina? Oh, when you say, I was asking what is case sensitive, right? Oh, okay. So case sensitive, right? The SQL commands are not case sensitive, right? SQL commands are not case sensitive. Okay. The table name, yes, right? The table name could be, right? Table name could be, depends on the database provider, right? To which provider you're working with, right? So yeah, it can be, right? But these are not case sensitive, right? The SQL commands are not case sensitive. Okay. So yeah, these can be case sensitive, right? The name of the table can be case sensitive. All right. Okay. All right. Okay. Perfect. Perfect. Right. So we have inserted the value, right? Inserted the data. Now, how do we check, right? How do we check whether it has been inserted correctly or not? We can do the simple select star from countries, right? You can do select star from countries and you can see the data is now coming here, right? One, name of the country is Spain, capital city is Madrid, official language is Spanish, right? So it is there. All right. Now, so that is read, right? So that is actually read, right? So the next one in your CRUD operations is read, that you've done, right? Create, you've done, you've created a table, you've inserted the data. Read, you've done, right? You've read the data. Okay. Now what we want to do, we want to update, right? We want to update. And also one more example in the read, right? You can see the where clause, right? You can see the where clause. Select star from countries where I told you where is working on the rows, right? Which rows do you want? Where official language is Spanish, right? So give me only that row where the official language is Spanish, right? So you press enter and you'll get only this particular row. Incidentally, there's just one row, right? So nothing else is there. But yeah, so where clause is working on that and it is giving you that particular row. All right, update, right? If you look at the update, update does what? So if you notice, right? If you notice, update is working on updating the data, right? It's working on updating the data. Now, what you do here, right? What you do here is update, right? Update is the command, and then you have the name, right? Name of the table, right? Update countries. Now you say set, right? You say set which column equal to what, right? So you say update country, set the capital city equal to Barcelona, right? The capital city has to be set to Barcelona. In which row, right? In which row do you want to set this column capital city equal to Barcelona? In which row? I want to do that in that row where the country name is equal to Spain. So whichever row has the country name is equal to Spain, in that row, set the capital city column equal to Barcelona, right? That is what we are doing. So you can update that, right? So let's just run this query and see if our update one, right? That means this has run, right? So this query has been updated. All right. If you want to see, right, you can do select star and you can quickly see, right, that. So you see capital city has been updated to Barcelona, right? So that is update. Okay. Similarly, you have delete, right? Delete is to delete any particular entry. You want to delete a particular row. So you can delete, and the command is what? Delete from the table name, right? From the table name, and you can have the where condition, right? Which rows? Because see, deletion is done on the rows. Okay. So which rows do you want to delete? So I said delete from countries, from the table countries where country name is Spain. So that particular record, right? So that one record is what I want to delete. Okay. So if you do that, so if we delete this, right, if we delete the record that we had inserted, so now if you see select star, right, we'll see that this has been deleted. All right. Okay, now you see we don't have any rows, right? We don't have any rows. Why? Because we've deleted. So delete command is what? You just said delete from which table, from the countries table, and which row, where country name is equal to Spain, that particular row we want to delete. All right. So let's take a few more examples, right? Let's look at a few more examples of this CRUD operation, right? So these are the CRUD operations: create, read, update, delete, right? These four are the most widely used, right? Most widely used: create, read, update, delete. Okay. So look at another one, right? Create. Okay. So what you can do is look at this example, right? Insert into actor. Okay. So you want to insert some. So we have the actor table, right? We have the actor table. And anytime you're not sure of it, you can always quickly do a select query, right? You can do select. Okay. Select star from actor, right? Select star from actor, and I want a limit, right? Because this will give me a lot of rows, right? So limit 2, right? So you can always see what columns I have, right? I have the ID column, I have the first name, and last update. I have all these columns. All right. So now I want to insert, right? I want to insert more records here, right? So I can say insert into this, right? So I say insert into the actor table, the first name, and last update. What values? The values that I want to insert is Emma, Boulder, and the this now, right? Now is a function, right? You see this now with these brackets, that is a function which will give you the current date time, right? It will give you the current date time. Okay, so these values is what I want to insert. Right now it says that this record has been inserted. Okay, so now if you want to see, if you want to see whether that has been inserted or not, what we do is we do select star from actor. If you do select star from actor, actually this will give you I think a lot of rows. So you see, when you get a lot of this, right, you can quickly press Q over here, right? You press Q over here, it will stop, right? Because see, when you do select star from actor, you saw so many rows were coming, you quickly type in Q and it'll quit, right? That is how you can work on this Codio here, right? Not in all SQL, but for Codio, I'm telling you. Okay, so if you want to see whether this particular has been done or not, right? This was actually inserted or not. So what you can do is you can say select star from actor, right? Where Now you tell me, right, what where clause can I add, right? What where clause can I add to check whether this particular data was inserted or not, right? What is the where clause that I can add? Select star from actor where what? What where clause can I choose here? Try, because now we'll go into the lab exercise, right? So you have lab exercises, and in that you have to type in the SQL queries, right? So better to give it here in the live chat so that I can tell you if it is correct or not, and then you can rectify accordingly, right? Ina says where last name equal to Boulder. Susan says where first name is equal to Emma, right? Yeah, both are correct, right? Both are correct, right? Great, Ines and Susan, great, right? So you can say where first name, right? Where uh first name first name is equal to, right? You can say first name is equal to Emma, right? Yeah, that also works. Okay, where first name equal to, okay, apparently there is something happening here, right? I might have to refresh this. Okay. Okay, I'll have to refresh this, right? Okay, we'll look at another where clause, right? We'll look at another where clause in the next segment, but that is how you can use, right? So where first name equal to this or where last name equal to this. And if something like this is happening, right? If Codio is not working correctly for you, always refresh it, right? Just refresh the page and move to, because sometimes it has these issues. All right. Okay. So read, right? We'll look at the where clause here, right? We can look at the where clause here in this particular example. Okay. So you can say, let's just select star, right? You can say select star from actor, right? Where actor ID is equal to 15, right? You can say where actor ID equal to 15 or actor ID equal to anything, right? So that is the where clause. That's the where clause that you can use. And this is giving a lot of bugs, right? Okay. Yeah, so this is how you can use the where clause, right? So wherever actor ID is 15, I'm getting that row, right? You get that row where the actor ID is equal to 15. Okay. Same thing for the first name and last name also you can use and do that, right? So that is also possible. Okay. Makes sense? Does it make sense? Any questions so far? Let me look at the live chat. Any questions? Perfect. Awesome. All right. Okay. So that is your read, right? So that is how you can read. Okay. Next is update, right? Again, the update. This is the same that we did earlier, right? And now you can look at this, right? It's another example, right? All the same, right? All the same that we did earlier. Okay. You update the actor table and I have to set the first name equal to Tom, last name equal to thanks, last update is equal to now, right? Where, which column, right? Where first name is equal to Emma, right? So this is the where clause, right? Where first name is equal to Emma and last name equal to Boulder, right? So this is where you want, right? First name is Emma and last name is the Boulder. This is the where clause that we were doing earlier, right? And was showing us errors, right? And it's the exact same where clause. Okay. So sometimes it might have bug. Hopefully this does not have any bug here, right? So yeah, it has updated, right? So it has updated. So now you can see, right? It has been updated. Okay. So let's try again, right? Let's try to select that particular row, right? Let's just select and see if it has got it correctly or not, whether the updation has been done correctly or not, right? So you just select, right, star. This is very slow, right? Actually, I've already typed it and it's not coming. Okay. So select star from, right, from the table actor table, right? We want from the actor table. Okay. And we want where first name, right? First name is equal to what? Is equal to Emma. Okay. Now, ideally, this should give us the row, right? Select star from actor where first name equal to Emma, right? So you see, this is not giving us any
Because Harshit, I think you need to insert it first, right? You first
We did,
insert
right?
and you do the select. But I'm not sure if this system like is working properly because it happened to me
Yeah.
the first time yesterday. So
Uh,
that's
Oh, I think
it.
I refreshed, right? Yeah, okay, okay. This does not
Yeah.
persist, right? Yeah, okay. Thank you. Yeah, thank you, thank you. So yeah, this is actually not persisting, right? So you have to insert it again. So once you do a refresh, right, it has gone, right? This database because it's in Codio, so it's not persisting, right? It is not keeping that data. Okay. So what you need to do is you need to do the insert part again, right? If you want, then you need to do the insert again. Okay. Yeah, right. So you have to insert this again, right? If you refresh it, then everything is gone, right? It starts from again. Okay. So you need to insert it again, right? Now you can do, right? Now you can do select, right? You can do select star, right? From actor table, right? From actor, okay? Where, first name, right? Where you want the first name equal to Emma. All right. There you go, right? There you go. Okay, so this was the same query. Earlier it was giving us bug, but after that I refreshed, right? And as soon as I refresh, this insertion has gone, right? So once you refresh, that's part of Codio. Okay, that's not part of SQL or database, because in actual database or in real database, once you insert it, it will persist, right? It is done, right? So it's you cannot it will not it's durable, right? The asset properties that you saw, it's durable, right? So it'll stay there. Okay, but here in this particular case, because we are working in Codio, right? So you refresh it, it is gone. Then you'll have to insert it again. All right, because we are doing practice over here. Okay, so you do select star from actor, right? And this is the where clause that you can use to see whether this has actually worked or not. All right. Okay. So that is it, right? So this is the read, right? And then we have the update, okay, that we saw. And yeah, that's about the update. And last is the delete, right? So these are your CRUD operations. Delete is just to delete it. What you do is you just delete from actor and you say where first name is this and last name is this, and you can delete the particular record, right? So delete from actor where first name is Tom and last name is thanks, right? And you delete it. All right. So delete one means it has been deleted. Okay. So these are your CRUD operations, right? CRUD operations are what? Create, read, update, delete, right? These are your basic CRUD operations. Now let's quickly go through this knowledge check, right? Let's look at this knowledge check. Question number one, let's see how much you've understood. Before that, let me see any questions here. Okay, Omari says not properly functioning, right? Omri, yeah, Codio sometimes has these issues, but whenever it is there, just refresh once or log out and log in once, right? In case you face any such issues, it resolves, right? After refreshing, it resolves. Okay. Question one, right? Look at question one. Which of the following database models is known for its tabular structure and use of SQL for querying the data? Is it NoSQL? Is it relational graph? Is it document? Or is it relational? Which of these is uh, known for its tabular structure? Okay, quickly tell me in the live chat. Stephen says D, right? Stephen says D. Bino says last update time is different, right? Yeah, last update is the time, right? Yeah, that's correct, right? That's the time, and that is saved with the now, right? Using the now function is the current time. Okay, D is correct, right? D is correct. Relational, right? That is absolutely correct, right? Well done. Okay, which database is most suitable for storing and representing complex relationships and interconnections, such as those found in social networks and recommendation engines? We talked about this, right? I showed you an example also. Is it linked list? Is it arrays? Is it graphs? Or is it stacks? Which one of these is used for complex relationships and interconnections, such as in social networks? C, right? Graph is correct, right? Graph is correct. Absolutely perfect, right? C is 100% correct, right? Graphs is correct. Okay, great. Perfect. Well done. Okay, question three. Which SQL operator is used to specify the number of rows to be returned in a query resulting from a Postgres SQL database? Okay, so you want to specify the number of rows to be returned in the query, right? Specify the number of rows to be returned in the query result. Okay, so which of these limit, select, from, where? Limit, right? A is correct, right? Okay, perfect. Awesome, awesome, right? Limit is correct. That is limiting the number of rows that you want to see in the output. Okay, which SQL query retrieves all columns from the employees table? Which SQL query is retrieving all columns from the employees table? Select star from employees, select columns from employees, select all employees, retrieve star from employees. Which of these is going to give you all the columns from the employees table? So it says A, right? Select star from employees, right? Binu says A, Ina says A, Stephen says A, right? That is absolutely correct, right? Select star from employees will give you all the columns. Why? Because select clause works on columns and select star means all the columns, right? So you're getting all the columns. Absolutely perfect. Okay. Last question. Which of the following SQL statements is correct, right? Which of the following SQL statements you see is correct and uh, is incorrect, right? Sorry. Which of the following is incorrect? Others are correct. One of them is incorrect. Select star from table name. Is this correct? Update table name. Set column 1 equal to value 1 where condition. Is this correct? Create table name, right? Column 1 data type, column 2 data type. Delete star from table name where condition, right? Which of these is incorrect? Means other three are correct, right? Three will be correct. One of them is incorrect. Which one of these is incorrect in the syntax? Bino says D, right? Bino says D. Stephen says D. Omri says D. Let's look at D, right? Delete star from table name where condition. Okay, others. So then says D, right? Okay, others. Are you sure D? Others, everyone. Is D incorrect? Yes, right. Okay, Valentina says yes. B says yes. Absolutely right. Yeah, I was just trying to trick you all. So D is correct, right? Select delete star is nothing, right? Delete star is nothing. So yeah, that is absolutely correct. Okay. Okay, so we'll stop here, right? We'll stop here for another break of 10 minutes and then we'll move on to the lab exercises where you'll practice and we'll see how much you have understood. All right. So going back to Raya, right? We'll have a quick 10-minute break. Thank you, Raya. And amazing DJ. Raya is always an amazing DJ. Love the songs. All right. Okay. Quickly sharing my screen. Give me a thumbs up if you can see my screen. Awesome. Thank you. So Stephen says perfect timing, right? Yeah, the song just finished and yeah, perfect timing. Absolutely. Raya is just a rock star DJ. All right. Okay. So now we'll move to the lab, right? This is the lab exercise. And we have two sets, right? We have two sets. This I want you all to do along, right? So because it's one thing to see me write the code and the queries, it's good to practice. Okay. So open the lab exercises, keep your lab exercises open, and we'll do these questions one by one. Okay. And you should do it on your own also, right? Type in the query and execute the queries also. All right. So this lab should be open, right? You can see from here, we are doing the CRUD operators actors. Okay, this is the lab exercise that we are doing. All right. Okay. So let's practice some CRUD operations on a table named actor, right? So actor table is already there that you saw. And if you want to quickly just cross check, you can do select star from actor, right? And use a limit here, right? Use a limit here. Why? Because if you don't use a limit, there'll be a lot of rows. Okay, so we can see this. Yes, the actor table is existing. It has the ID, first name, and last update. Okay, so this is the structure, right? This is a structure. Now we have some tasks, right? So some task has been given to us. First is retrieve the details of the actors with the first name Kenneth. Okay, retrieve the details of the actors with the first name Kenneth. Okay, now you'll type in this query, right, and tell me the query in the live chat. I'll take your queries, right, and then I'll run it and we'll see whether it is correct, incorrect, or what you all have missed out on. Okay, so open, right, open your lab exercise, right, write your query over there, execute it, right, show me in the live chat what you get, and tell me the details, right? So basically, what is the first name, right? Give me the first name of the actor with the first name is Kenneth, right? Okay, first name is Kenneth. Give me the last name, right? Sorry, the first name is Kenneth. Give me the last name or give me the actor ID. Okay, anyone. Give me the last name, right? Actually, give me the last name. That will be more clear. Okay, so give me the query, right? Binu says select star from actor where first name equal to Kenneth, right? Okay, Binu, great. Have you run this, right? Have you run this query? And others run this query, and yeah, looks correct to me. Binu looks correct to me, but others try, right? Try execute the query, right? Execute the query in your lab exercise and tell me what is the last name, right? What is the last name of Kenneth? Okay. Valentina says same, select star from actor where first name equal to Kenneth, right? Okay, but what is the last name, right? What is the last name of Kenneth, right? That is the question that I'm asking. Okay, that you all can't get it unless you all run the query, right? So you all can type the query here, which is correct, right? Looks correct, right? Valentina, that is correct. We know that is correct. Okay. Okay, Valentina has given the screenshot, right? Perfect, right? Great, awesome, awesome, right? Yeah. So Kenneth, and there are multiple actors, right? So absolutely correct, right? Yeah. So the query looks correct, and select star from actor where first name is Kenneth, right? So yeah, you get all these multiple people with Kenneth, right? So yeah, if you want any specific, now you understand why the ID column is important, right? So if I'm talking about one particular actor, right? If I'm need a specific one, then I'll ask for the ID, right? What is the ID of the actor so that I can get the details of that particular actor? Okay, because first name can repeat, right? But the ID cannot repeat. That's why the ID is always unique, and this is what is known as a primary key. We'll discuss more on primary key, foreign key in our next lesson, that is next week. But this is the primary key, right? That means this cannot repeat. Okay. Second task, right? Add a new actor named Bruce Wayne, right? Add a new actor named Bruce Wayne to the table. Okay, this is not actually a typo. They have purposely done this, right? Instead of Bruce Wayne, they've done is Bruce Wayne, right? Okay, add a new actor named Bruce Wayne to the table, right? Quickly tell me the query, right? Type in the query here. There is no way I can check, right, whether you've executed the query or not. But yeah. Okay, Ines says 4 entries, right? Well done, Ines, right? Well done. Perfect. That is absolutely correct. Okay. Valentina says insert into actor, right? Okay, insert into actor, first name, last update, values, Bruce, wine now, right? Yeah, Valentina looks correct to me, looks correct. And then select first name, last name from actor where actor ID equal to 7, right? How do you know actor ID will be 7? Oh, that's the next answer you are giving, right? Oh, answer for this one. Okay. Okay. Let's do task number 2, right? Let's first do task number 2. All right. Valentina is on fire. Right. Okay. So yeah, this looks correct to me, right? Looks correct to me. Others, is this correct, right? Is this correct, or any mistake do you see here? Insert into actor, first name, last update, values, Bruce Wayne now. Is this looking correct? Anyone wants to give any other answer? Venus is insert into actor, first name, last update, and values Bruce Wayne now, right? Yeah, that is correct. Stephen says insert into actor, first name, last name, value. Values, right? Stephen, it will be values, right? Not value, right? Value is incorrect, right? That S has to be there. Okay. And values should be capital, right? Capital. Small also work, right? Small also work. It's not case insensitive, but it's not case sensitive, but convention, right? For convention should be values. Okay. Capital. Okay. Insert into Jordan says insert into actor, first name, last name. Bruce Wayne, right? Jordan, you need the last column also, right? You need the now also. Okay. And Stephen, you had one mistake, right? Stephen, you had one mistake. Okay. So you say insert into actor, first name, last name. See, you are saying only 2 columns, right? I'll take this as an example, right? It's good for you all to understand this. Okay. See, Stephen, you have given this, right? Look at this. Okay, you say insert into actor, right? You say which columns. I'm saying I want to insert into first name and last name. So you've given that, okay, in these 2 columns I will insert some values. Okay, in these 2 columns, first name and last name. But what values you are giving? This one we had already discussed, right? It will be values. Okay. But what values you are giving? You are giving 3 values. You're saying Bruce, wine, and now. But you've taken only 2 columns, right? First name and last name. So you cannot given 3 values here, right? You can only give 2 values, right? Only these 2 values, right? If you given only 2 values, then work. The number of columns that you have, because it's all corresponding. The first one will go here. Okay. The second one will go here, right? Imagine like arrows. First one is going here. Second one is going here, right? The third one will go in the next one. Okay. So if there's a mismatch here, right? If there's a mismatch here, then it will not work. Okay. Makes sense, right? Makes sense. Omri says insert into actor, last name, values, Bruce Wine now. No, Omri, that's not correct, right? Omri, that is not correct, right? See, first thing, insert into actor, right? Insert into actor, that is fine, right? Insert into actor. After that, the first bracket has to come, right? First bracket is for the set of column names. right? In which columns do I want to insert the values, right? So first bracket has to be this, okay? It's this part has to be there, right? So this bracket is missing for you. So see, the syntax is like this: insert into table name, right? Whatever is my table name, okay? Here, then this bracket, right? This bracket is important. This bracket has to be there. Now inside this is where you'll write the column name, right? This comma this, right? These three columns or two columns, how many columns? Okay, then you say values, right? Values, and then again a set of bracket, right? Again a set of bracket. And what values you want, right? In the first set here, what value do you want to send? You keep that value over here. Let's say 4, okay? Then 5, then 6, right? So 4 is going here in this space, okay? 5 is going here in this particular column, right? 6 is going here in this column, okay? That is how you need to specify it. Make sense, Omrai? Okay, perfect, right? Jordan says, yeah, but it's there without it, right? Okay. Jordan said, like last update is a default column, no, so it will still populate. Last update is a default column. I don't know if we had kept it as default column or not, right? Last update was kept as a default column. That depends while you're creating the table, right? While you're creating the table, depends on that. Valentia says all columns were mandatory when table was created normally. Okay. Valentia says, what did I do here, right? Stopped. Okay, so it stopped working, right? You need to refresh, right? Valentina, sometimes Codio does that, right? Codio has all those issues, right? You need to refresh, right? Nothing wrong done by you. Just refresh the page and you should get it. Okay, so yeah. Okay, so let's run one of the queries that you all have sent, right? And let's see if this is correct or not, right? Stephen, Jordan, right? Jordan has sent this insert into. Okay, let's try without the now, right? Without the third column, right? So insert into actor, first name, last name, values is Bruce Wine, right? And without the last update, right? Let's see. Okay, so yeah, it's inserted, right? It's inserted. Okay, so yeah, that is correct, right? It inserts. All right. Okay. So third one, right? Third one is change the last name of the actor with ID 7 to Streep. Okay, so you want to change the last name of the actor with ID 7 to Streep, right? So you need to update. Okay, so that's the keyword. Okay, so tell me for the third one, right? Try the third one. Change the last name of the actor with ID 7 to Streep. Jordan says not trying to be difficult, but less is more. No, if it's not necessary, at least in my opinion, it's irrelevant. Absolutely correct, right, Jordan? No, that is correct, right? That is correct. That optimizes, right? That optimizes, and that is correct, right? That is correct. That should be there. Okay, that is absolutely true. But here we are just practicing, right? It's for practicing. It's for you to understand, and though those who are new to SQL, right? Someone who does not have any idea about SQL, they want to practice, right? They want to understand all this, right? So it's from that perspective. All right. Okay. Okay. Do this one, right? Do the third one, right? Change the last name of the actor with ID 7 to Streep, right? Okay. Valentina had already done that. But others, right? Others, do this one. Change the last name of the actor with ID 7 to Streep. Valentina says, oopsie, right? Valentina, you can go to the fourth one, right? Try the fourth one, right? Go to the third or fourth one. Remove the actors with the last name Vine from the table. Okay, Valentina, you can try that. Try it at your in your Codio, right? Try that and post it here when we move to that, right? Oh, it's a stuck, right? Okay, Valentina's this is stuck, right? Refresh, right? Does refresh work? Valentina, refresh your Codio, right? Refresh, it should come back again. Okay. Okay, others, this one, right? Change the last name of the actor with ID 7. So you want to change the last name. Okay. So what do you want to do? You want to update, right? So keyword here is update. Okay. Update what? And he says, I'll do everything again while studying, right? Yeah, that's also perfect, right? Valentina, yeah, that's perfect, right? That's also a great idea, right? Yeah, I should revise later on, right? Absolutely perfect. Okay. When they select first name, last name from actor where actor ID is 7. First you see the row, right? Yeah, okay, we can see the row first, right? Yeah, let's look at the row first. Okay, let's select this, and you can see what exactly is the row first. Okay, so the first name and last name is Grace Mostel, right? Grace Mostel is the first name and last name. You want to change the last name to Streep. Okay, last name you want to change it to Streep. Type it here, right? Type it here, type the query, right? Type the query. See, it's an update, right? What we need to do is update. We've done this, right? We've done this update. Okay, what you need to do is update. Okay, update what? Update which table? Update actor, right? Update actor. And you want to set, right? Set is the keyword. Update set what to what, and how, right? Now, okay, when it says update actor set last name equal to Streep, where last name equal to Mostel, error, syntax error at or near this, right? Line 3, where last name equal to Mostel, right? Okay, M must be small, right, Valentina? M must be small of Mostel, or all capital, right? Mostel, all are capital, right? So you need Mostel, all capital. Okay. Bino says update actor set last name equal to Steve, where actor ID is 7. That is correct, right? Looks correct, Bino, to me. Absolutely correct. Stephen says update actor set last name equal to Streep, where actor ID is equal to 7, right? Yeah, absolutely correct, right? Stephen, that is correct, right? Stephen, correct. Bino, that is correct. Okay. This looks correct. Update actor, right? Update this particular table. Set which column you want to set to what value, right? The last name column I want to set to the value Streep. Okay. In which row, where the actor ID is equal to 7, in that particular row. Okay. So this should be updated, right? Now let's quickly check whether it has been updated or not, right? Let's see, select first name. Yeah. There you see, right? Now the first name from Grace has been changed to Street, right? Earlier it was Grace Mostel. That has been updated to Grace Street, right? So that is your update, right? So once again, for your revision update, you do what? Update the table name, set the column name, right? Which column name, right? So last name, right? I want to set the last name equal to what, right? The new value that you want to set, right? Street or whatever value you want to set, right? This is the new the new value that you want to set to, right? Updation. Okay. And the where clause, right? Where clause is for which row, right? In which row you want to do this updation, right? So that is where your where clause is for. For that, they have given you the ID, right? Actor ID is equal to what, 7 or 17, 7, right? I think, yeah. Okay, act ID 7. Okay, so that is how you update it, right? Remove the actors with the last name Vine from the table. Okay, last step, right? Remove the actors with the last name Vine from the table, right? So you need to delete it. The last name Vine, right? Whichever actor has the last name Vine, remove that from the table. Okay. So which keyword, right? Which keyword will you use? Okay, Jordan says delete from actor where last name equal to wine, right? Venus is delete from actor where last name is wine, right? Looks correct, right? Perfect. Looks absolutely perfect, right? Delete from actor where last name is equal to wine. And you delete from actor where last name equal to wine, right? Perfect, right? Absolutely perfect, right? Absolutely perfect. You all have perfectly got it, right? Looks 100% correct to me. Delete from this particular table, right? Delete from the actor table. Which row I want to delete? Whichever row has the last name where last name is equal to wine, right? That particular one, delete it, right? It's absolutely perfect. Okay, so that delete has been done, right? Great, awesome, right? So these are the 4 queries, right? 4 queries. Write these down over here in the submission box before you submit. Okay, practice on your own later on, right? When you're going through this again, and write these 4 queries here and submit this answer. All right, let's move to the next lab exercise, right? We have another set of questions. Okay, now we are doing some CRUD operations, create, read, update, delete operations on countries, right? So first, right, let's see whether the country table is existing or not, right? This table should be there. Select star from country, and see if you get like this, right? Quickly type in Q. Okay, otherwise it will get stuck because you need to use limit. Okay, so use limit. Okay, limit to 2, and just see the structure, right? So we have a country ID, we have country, and we have the last update, right? So we have these 3 columns. All right. Now the first task, right? Look at the first task is retrieve a list of countries from the country table, limiting the results to 20 countries only. right? Okay, I've already done this, right? Limit 2, so I just need to add 0 here, right? So select star from country, limit to 20, right? Retrieve a list of countries from the country table and limit it to the first 20 rows. Okay, so just need limit 20, right? And there you get the first 20 results. Okay, so don't worry about the first one. Okay, look at the second one, right? Update the entry for the country Turkey in the database to Turkey, right? So update this, right? Update Turkey to Turkey, right? Update again the same thing that we did last in the last lab exercise. Similar update. Okay, now I want to see others, right? Others who had not given the response. Okay, give me the update, the query to update. Omuri says update actor set last name equal to streep, right? Last update equal to this, where actor ID is. No, Omuri, see, that is not correct, right? See, I'll show you, right, where the mistakes are, right? Let me take this here, right? Omuri, see, what you're doing is, okay, you say update actor table, right? I want to update the actor table, perfectly fine, right? I want to set what? I want to set the last name column equal to streep. That is perfectly fine. But the streep, right, when you have this inverted commas, this inverted comma should end over here, and no semicolon, right? Semicolon does not come here. Semicolon means that's the end of your query, right? Semicolon means query is over, right? So you don't have any semicolon here. Okay, last update, this does not require, right? This is not required, and all you need is where actor ID is equal to 7. That is fine, right? After this, you can have a semicolon, right? So that's perfectly fine. All right. Okay. Minu says update country, set country equal to Turkey, where country equal to Turkey, right? Looks correct, right? Looks correct. Valentina, the first one is correct. All right. Others, right? Give me the update, right? Update query, right? Update query. Give me the update query. It's others, right? Who have not answered. Okay. Otherwise, I'll call out names, right? Shall I call out names? Okay. Ines, have you done the update query? Stephen, update query done. BB, update query done. Suzanne, update query done. Have you done the update query? Susan says update country, set country equal to Turkey, where country equal to Turkey, right? Okay, so I'll take Susan's one, right? Okay, looks correct, right? Absolutely. Ines says yes, right? Great, Ines, well done, right? Okay. Stephen says update country, set country equal to Turkey, where country equal to Turkey, right? Absolutely correct, right? Absolutely correct. You all have got the hang of it, right? You all have understood the concept, right? I can just see that, right? It's absolutely correct, right? This query is correct, right? Update country, right? Country table, set country equal to Turkey, where country is Turkey. Absolutely correct. Okay, perfect. Third one, insert a new entry into the database for the country South Sudan, right? Insert a new entry into the database for the country South Sudan, right? So you need to insert a record. Okay. Insert a new entry into the database for the country South Sudan, right? Now quickly give me the query for this. When it says insert into country last update value South Sudan now. Okay, Jordan says insert into country last update values South Sudan now, right? Absolutely perfect, right? Yeah, looks perfect. Looks perfect, right? Bino says insert into country last update, value South Sudan now. Absolutely perfect, right? Absolutely perfect, right? You all have understood it, right? So insert into, right? The query is insert into which table? Insert into the country table, okay? Then you have a set of brackets, right? Set of brackets to say in which columns, right? I want to add values in the country column and the last update column, okay? What values now? You say values, and what are the values? The values you want is South Sudan, comma, and now, right? Now is a function which will give you the current date time. All right, so that insert has been done, right? Perfect, right? Awesome. Okay. Fourth one is retrieve a list of countries from the country table, sorting them in descending order by country name. Okay, this one I have not discussed, right? Ordering and sorting, but let's see if you all know it or not, right? Retrieve a list of countries from the country table, sorting them in descending order by the country name. Okay, so you want the list of countries, right? Sort them in descending order of the country name. Okay. Uh, Samson says insert into country. Okay, Samson, that is correct, right? Absolutely correct. Wonderful. Jordan says select star from country, order by country, DESC, right? Okay. Uh, Great, right? Wonderful, Jordan. Wonderful, right? Appears you already know SQL. So that is correct, right, Jordan? That is correct. And so the query here is select star from country and order by, right? See, order by is the clause to do the sorting, right? So you want to sort, say, I'll quickly take it over here and tell you. Okay, you say select star means what? Get me all the columns from which table? From the country table. Now I'm saying the result that you get, right? See, this will give you all the columns and all the rows, right? Gives you all the data. Okay, now if you want to sort it, right, the output, you want to sort the output, you say order by, right? Order by means what? I'm saying order by the country column. Okay, order by the country column, that means arrange it in the order of the country column. Okay, by default it will be in ascending order, so this is alphabetically in country name, right? So alphabetically the country with A will come first, then the country with B, then C, right? So alphabetically. Okay, but if you want it in reverse order, right, in reverse alphabetical order, you say DESC. DESC means in descending order. Okay, so the country with Z will come first, right? Then Y, then X, right? So on and so forth. Okay, so DESC is in descending order of the country format. Okay, so that is the correct query. Make sense? So order by is not actually working on your query. It is just when your suggestion put limit, right? Yeah, absolutely, right? Absolutely. Okay, yeah, that is correct, right? Limit should be put, okay? Because you have a lot of you have a lot of this, right? A lot of rows are there, and it'll just give us a lot of rows. Okay, so you see this, right? You see this? Zambia is coming first, right? The country is with Z first, then Yugoslavia Y, Yemen Y, then we. Okay, so it's in reverse order. Why? Because we did an order by. So order by is what? It's just doing a sorting, right? You just sort based on this particular column, whatever column name you provide here, right? It'll do a sorting based on that. Okay, now this is not a part of the internal query, right? It's the output is being sorted accordingly. You get your subset of the data. So let's say you have this data, right? You have this data over here. I get the subset, right? The subset is got to me. Now I do the sorting in the output, right? You sort and then you display the output. Okay, so that is how order by works. All right. Okay. Uh, when you say, oh, but we had the solutions on this lab, right? Yeah, the solutions is there, right? Yeah, solutions is there, right? You scroll down, the solutions is there. Lab exercise is just for your practice, right? It's for your practice, not to test you, right? Don't worry, right? For practicing, you'll have your mini projects and a lot of stuff will be there. Assessments will be there for your for your uh, checks, right? Knowledge checks. Okay. But yeah, so this is for your practice, right? But highly recommended that you don't look at the solution, right? First, work on this, right? Play around in this lab exercises, get the results, right? Try to work on it, and then check the solution whether it is matching with your this or not, right? Whether you made any mistake or not. And once you finalize your query, paste in your queries over here, all the 4 queries, and then click on submit answer over here. All right. Okay, so we move forward and let's move to the conclusion, right? So this is the conclusion and the key takeaways that we had. Okay, so basically today's lesson provided a comprehensive overview of the databases, focusing on relational, non-relational types and along with their respective advantages and disadvantages. We delved into the essential components of both types of databases. We emphasized the fundamental differences between relational database like SQL and non-relational database like MongoDB, highlighting their suitable use cases. Additionally, we explored basic SQL commands like select, insert, update, delete, which are crucial for managing and manipulating the data in relational databases. Okay, this is mostly for the CRUD operations. So these are the key takeaways. We gain a thorough understanding of the essential components of a database, including tables. A database consists of essential components, tables, records, field, indexes, and relations. Relational database like MySQL, Postgres, and Oracle rely on structured query language, that is SQL. That is the query that we were running. Okay. Basic SQL commands is what we did, including select, insert, update, and delete. These are the fundamental tools for managing and manipulating data in relational databases. Mastery of these commands enables tasks such as querying data, validating test results, and managing test data. These are the critical skills for software tester. Okay. Further reading, you have some links for further reading, and you can check these also. And you have the self check, right? Self check exercise is there that you can uh, put in the number, right? The most likely you all must be familiar with this now, which number you need to put based on the question. You put in that number over here. Okay, and additionally, if you want any practice, right, I'll show you this website also. There's a lead code that you can sign in to this website, and you can always practice more of SQL over here. You can target the easy, right? So there are easy, medium, and difficult set of questions. You can target the easy ones, right? That gives you more practice in SQL. Okay, so that is the thing, right? Now let's move to I'll quickly go into the Miro, right? We have this Miro, okay. I'll quickly review this, and this link is there, right? This link is there. I'll share it in the live chat over here, right? Add in the responses, right? Add in the responses for the reflection, anything that you feel in this lesson, right? So I'll go through the review quickly of what all we did in SQL fundamentals. We did the database management systems, right? You understood about what an entire database management system is. It is not just about the hardware, right? The hardware is where the data is actually stored, but the entire management system includes the hardware, it includes the software, it includes the actual data, the procedures for installing and managing the data, right? You have the database access language, you have the users, right? All put together is the database management system, right? Examples we saw was MySQL, Microsoft Access, right? SQL Server, Oracle database, okay? You have the different types of databases, right? Relational versus non-relational, SQL versus non-SQL. You saw in-memory database, right? Like Redis, object-oriented database. You saw graph databases, right? You saw time series database, right? So all these different databases. Then we move to the asset properties, right? Asset models. You saw what is atomicity, what is consistency, what is isolation, durability, right? Oh, those are the asset models. Then we worked on the SQL operations, where you saw the CRUD operations, right? Create, read, update, delete. We saw these different operations. We did the DDL, right? DCL, DML, right? Data manipulation language, data definition language, and data control language. All right. So these were the things that we discussed, right? In this reflection, right? Write down, right? Write down if you have any reflection points here, right? You can point it down. This is a good mind map to see what you're feeling and how you've understood which part you have gathered mostly from your responses. I see you all have understood most of it, okay, but any parts, right? Any parts, let's say you liked any part the most, right? Post it here, right? Type it here. And any part that you did not like much, right? Post it here. Rest, make sure to add your points, right, to the mind map, right? Yeah, please do, right? Please do add your points to the mind map, because it's important for us, right? It's important for us to understand how much you have understood. See, if you liked any part, just type it in over here, right? You can type it in over here, and in case, let's say, you need help with something, right? Or you're confused with some parts, let's say the update, or let's say the SQL queries, right? Update, delete part, or any parts, right? You can add it over here, right? You can add it over here, okay? Or if you have some doubts in some parts, right? You can add here, right? Or some key takeaways, you can add it over here, okay? Quickly, I'll give you a few minutes, right? I'll give you a couple of minutes more, and then we'll move on to the Kahoot, right? The Kahoot challenge. Okay, so that will be fun, right? That will actually show, right, how much you all have actually understood or not, right? So Kahoot is coming, right? Kahoot competition is coming quickly. Okay, so quickly, right? Giving you 2 minutes for this mind map, right? Type it down here, right? So even if you have not understood some part, right, type in this, right, in this section, confused, right, in this blue part, right, in this blue confused part, you can type in that. Let's say I found this part confusing, or this part was not good. Okay, so then you can then Seraphim, or we can follow up on that, right? And you can see if the help, right? Or if you've understood, right? If you've understood everything perfectly, right? The CRUD operations, right? Create, read, update, delete. We'll do more SQL queries, right, in the upcoming lessons. Okay, so don't worry about that. You'll have more of joins, and more complex stuff will come. But so far, CRUD operations should be absolutely clear to you. Create, read, update, delete, right? So those should be clear to you, right? Okay. Okay, see, I someone has mentioned, love this shared lab part of the lecture, more interactive and easy to follow, right, Valentina? Okay, great, awesome, right? Yeah, that's the idea of the lab exercises, right? It is supposed to be interactive, right? You all do it, and you all type it, right? You all actually do, because it's one thing to see me type it, right? And it's absolutely another level to get your hands dirty and type in. Okay, so do that, right? And you need to practice more, right? So therefore, do the lab exercise again, and I sent you the lead code, right? That is also there for your practice, where you can practice more of your SQL. Okay. Uh, Good to refresh the fundamentals, right? Yeah, good to refresh the fundamentals. Absolutely, right? Absolutely. If you already know SQL SQL, then yeah, this was a good refresh for you. And yeah, in the next lessons, we'll have more complex stuff coming, right? So that is there. Okay. Hands-on lab was really interesting, right? I see hands-on labs was really interesting. Awesome, right? Great, great, perfect, right? Glad to hear that. All right. And okay, someone is confused with some part. Will need to have a better understanding of APIs, Valentina, right? Yeah. APIs, right? Valentina, absolutely, right? Let me see after Kahoot, right? After Kahoot, if I get 5 minutes, right, I'll tell you more about APIs. Or you can always schedule a one-to-one with Seraphim, right, and discuss one-to-one with Seraphim about APIs and how that is. And if not, right, if not, we have a dedicated lesson on APIs as well, right? I think it is API testing, right? You have a dedicated mini project on that also, right? So that'll come up. Okay, so you have a lot of APIs coming up your way, so don't worry about that at all, Valentina. Okay. Okay, I see CRUD operations are easy to understand, right? Great, great, awesome, right? Awesome. Glad to hear that CRUD operations are easy to understand, right? Yeah. Okay, yeah, because those are the fundamentals, right? Those are the building blocks for your SQL, right? For any database, and not just SQL, right? Any database, right? These CRUD operations. How do you create, you read, update, delete, right? Always keep this in mind. Okay, they are always the basics for any database that you work on. Okay, and once you understand SQL, SQL, right, then moving on to different databases will be much easier. All right. Okay. Okay, last minute, right? Anyone else typing anything, right? I'll just wait for last 1 minute and then I'll move to Kahoot. All right. Okay, I see one more comment, right? Best way to learn, in my opinion, however, we need to we need to take time to do the operations, right? Yeah, absolutely, right? Absolutely. See, the lesson is designed to give you the basic fundamentals, right? Now you have to go back and revise, right? You have to go through it again. You have to practice again, right? You have to do that. Okay, that is the idea, right? That is the idea. Okay, absolutely, absolutely correct, right? So yeah, that is the idea. You have to go back, right? You have to revise it again. You have to. That is why the assessments and many projects are there, right? Assessments will force you to do that again, right? Go through those concepts again. Okay, and the mini project will help you do that again, right? And that is why I want you all to do the lab exercises again, right? The entire both of the labs, do them again, write in the query, play around, right? And you can think of some queries on your own also, right? Think of, let's say I have the actors table, I want to get this, right? I want to see this, right? I want to check this. Okay, feel free to play around, right? Feel free to play around. That lab in the Codio is for you all to practice. Okay, so feel free to do that. All right. Okay. Okay, so I'll stop here, right, with the Miro, right? Thank you all for the feedbacks and the points that you all have entered, right? That is very, very wonderful and helpful. Okay. Okay, so let's start with this Kahoot, right? Host live. All right. Let me host this live and let this load. And also the lead code, right? Lead code that I shared with you. Okay. Okay, the lead code website that I shared with you, right? Use that also to practice your SQL, right? You can have you'll get SQL questions over there, so you can practice that, right? You can practice that. Okay, okay. Join in the Kahoot, right? Join in the Kahoot. The link will be shared in this, right? Yeah, the Kahoot link is shared by Raya, and the game pin is also there. Okay, join into the Kahoot, and I'll just wait for 1 minute. Join in. And today I want to see a great fight, right? I want to see a great fight because most of you all have understood the concepts, right? I can see it from your answers, right? From your knowledge checks and from the lab exercise answers, right? You all have understood, right? You all have understood. So the fight should be good, right? Okay, go for the correct answers and see the faster you type, faster you click on the answer, the more points you get. Okay, so it's not just about getting the correct answer; it's about who does it faster also. But at the same time, don't make a error, right? Don't press an incorrect answer. Okay, okay, just waiting for 1 more minute, right? 1 more minute. Anyone enter the Kahoot competition, right? It's going to be a, I'm expecting a good fight, right? I'm expecting a good fight. Don't uh yeah, let's see. Okay, anyone else joining? Okay, 10 seconds more. All right, okay, I'm starting, right? I'm starting. All right. Okay, all the best to you all the best. And here we have the first question. Okay, SQL fundamentals. Okay, that's not the question, that's the topic, right? Yeah, 3, 2, 1, and let's go. Okay, which SQL command retrieves all columns for records where the age is greater than 30 in the employees table? Okay, so you have an employees table. Which SQL command retrieves all columns for records where the age is greater than 30? Read star from employees where age greater than 30. Fetch all from employees where age is greater than 30. Select age from employees where age is greater than 30. Select star from employees where age is greater than 30. Which of these options? Which of these options? Awesome, right? All of y'all have got correct. Only one incorrect, right? Okay, okay. So perfect, right? Select staff from employees where age is greater than 30. That is absolutely correct, right? Okay. So let's see who was the quickest, right? Ines, right? Awesome, awesome. Valentina's also just there, right? Theodora. Okay, all in the competition. All right. Okay, let's look at the second question. Okay, which of the following is not an example of a DBMS, right? Is Microsoft Excel, Microsoft Access, FileMaker Pro, MySQL. Not an example of a DBMS, right? It is not a DBMS. Excel, Access, FileMaker Pro, MySQL, right? Which of these, right? Which of these? Not a DBMS. Okay, four have got it correct, right? A lot of y'all have got incorrect. FileMaker Pro, right? No, FileMaker Pro is actually right. Okay, I can understand why it's confusing, but yeah, it is actually a DBMS, right? FileMaker Pro is a DBMS. So Microsoft Excel is not, right? Microsoft Excel is actually not, right? So yeah, a lot of y'all have got it incorrect. Okay, so that gives new people the lead, right? Hip hop is on the lead, right? Awesome with 1565. Jixing is second with 1442. Jordy is at 1248, right? Awesome, awesome, right? Okay, okay, let's move. Still not over, right? Which database would you select for an application that requires asset compliance and complex querying capabilities? Okay, which database would you select for an application that requires asset compliance and complex query, right? NoSQL database, relational database, in-memory database, or a graph database? Requires asset compliance and complex query capabilities. Absolutely right. Relational, right? Relational is perfect, right? We talked about asset. Okay, we talked about asset properties, right? Those who have got it incorrect, we talked about asset properties, right? They're there for relational databases, right? So absolutely right. Great. Let's see who's Jordy is in the lead now, right? And Jordy's on fire. Valentina back to second, right? Ines on third, right? Yeah, great fight happening here. Very close, right? Very close. Okay, so BB on your on the next question. Okay, which SQL command is used to remove a record from the customer table where the customer's ID is equal to 15? Okay, you delete from customer where customer ID equal to 15, remove from customer where customer ID is 15, erase from customer where customer ID equal to 15, or drop from customer where customer ID equal to 15. Which SQL command will you use? Delete from, remove from, erase from, drop from. Great, awesome. Everyone has got it correct. Okay, one incorrect, right? Okay, okay, but perfect, right? Yeah, this we did, right? We did this so many times in the lab exercise. Delete from customer where customer ID is 15, right? Absolutely correct, 100%. Okay, well done. Let's see. Ines is back in the lead. Okay, awesome. Valentina close behind in second. Jordy's third, Hip Hop and Binu trailing behind. Awesome. All right. Fifth question. Which command is used to change the salary of an employee with employee ID 101 in the staff table to 50,000? Okay. Alter staff set salary equal to 50,000 where employee ID is 101. Update staff set salary equal to 50,000 where employee ID is 101. Modify staff set salary equal to 50,000 where employee ID is 101. Change staff set salary equal to 50,000, employee ID is 101. Okay. Okay, eight I've got correct, right? Absolutely right. Perfect, right? Yeah, update is correct because we did this, right? Update is done. Alter, I just want to tell you, alter is also done to modify, but alter is to modify the structure of the table. Let's say you want to add a new column to the table, or you want to change the data type of a particular column, right? Or the name of the column. That is what you use alter for. So alter is for the structure of the table. Okay, but inside that the records, right, that you want to update, if you want to change the rows, the values in the rows, right, then you use update, right? That is correct. Okay, all right, awesome, right? Well done. Moving to the next question, right? Let's see what is the standings. Oh, Valentina is in the lead, right? Great, Valentina. Awesome. You're in the lead. Ines is trailing behind second Hip Hop and then Jixing and then Jordy, right? Awesome, awesome. Right? It's going a tough fight, right? It is going a tough fight as expected, right? As expected. Okay, question number 6. Which SQL command is case insensitive? Can be written in uppercase or lowercase without affecting functionality. Okay, which SQL command is case insensitive? Limit, select all of these or delete. Which of them is case insensitive? It can be written in uppercase or lowercase without affecting the functionality. Is it limit, select clause, all of these or delete? Which of these? Everyone's got it correct, right? Awesome, awesome, right? Okay, one incorrect. Okay, all of these, right? Yeah, we discussed, right? We talked about this in the beginning, right? So great to see y'all were paying attention and y'all have understood it, right? So yeah, all of these, right? Because it's case insensitive. Okay, you type it in small letters or capital letters, does not matter. Okay, let's look at the standings. Valentina still in the lead, right? Great, awesome. Ines is close, right? Very close, very close. 4416, 4453. Hip hop is third, right? Also very close. B was also four, right? Okay, all in 4,000s, right? Yeah, very, very close, right? Okay, okay, awesome, right? Moving on to question number 7, I think. All right. Question number 7. The combination of data, the DBMS, and the associated applications is referred to as what? The database framework, the database system, the data repository, or the database interface. The combination that I talked to you about, right? The data, the DBMS, and the associated applications. Together, it is known as what? Data framework, database system, data repository, or database interface. Which of these? Awesome, right? Most of y'all have got it correct. Database system, right? Database system is absolutely correct that we discussed, right? The data, DBMS all put together. That is the entire database system, not just the physical data part, right? Absolutely. Well done, right? Well done. All right. Oh, Valentina is still in the lead, right? Ina's very close behind. Bino is also close, right? Jixing and Susie has entered the top 5, right? Great. Awesome. Okay. All right. Let's see. We have 3 more questions left, right? Oh, 3 participants have reached answer streak 5, right? Wow. So 3 participants you all have got 5 correct in a row, right? 5 correct in a row. That's just 5 correct streak. And 3 participants. Oh, that's incredible. I think I'm seeing this for the first time. 3 participants with a streak of 5. Wow, great, right? Amazing, amazing. All right, eighth question, right? Eighth question. In the query, select star from actor limit 10. What role does limit clause play? Limits the number of columns returned, limits the number of rows returned, limits the data type of the columns, specifies the table name. Which of these 4 does the limit clause play in this query? Select star from actor limit 10, limiting the number of columns, limiting number of rows, or what? Right? Absolutely right. All of y'all have got correct. Most of y'all have got correct. Limiting the number of rows, right? Absolutely right. Limit, as we saw, it's reducing the number of rows that comes in the output. Right. Well done. Okay, let's see. Valentina still in the lead, right? Ines very close behind. Okay, Susie is in the third position, right? Great, awesome. Bino is there and Jixing is there, right? Awesome, awesome, awesome. Okay, we have now Bino has a streak with 7 correct answers. Bino, wonderful, right? The 7 correct answers in a row. Okay, I think Bino should receive a special prize, right? Yeah, Raya, Bino should receive a special prize for 7 in a row. Bino, let's see you can get 9 in a row or not, right? Okay. All right, let's move to the next question. I think only 2 questions left. Yeah, all focus, right? Full focus. All right. Okay. Okay. Where would you most likely store complex relationships such as social networks or recommendation systems, right? Complex this, right? In a graph database, in memory database, object oriented database, or time series database, right? You want to store complex relationships such as you do in social networks or in recommendation systems, right? Which kind of database will you use? Graph database or in memory database, object oriented database, or time series database? Which of these would you use, right? All of y'all have got it correct, right? Absolutely. Graph database is 100% correct because I showed you an example of that also, right? Great, right? Absolutely correct. Valentina still in the lead, right? In the top. Ines is close by second. Susie third. Jordy just hit the streak of 3, right? Awesome, Jordy. Well done, right? Okay, last question. Which CRUD operation in SQL is associated with using the insert into command? Which CRUD operation using insert into? Is it read, delete, or update, or create? Right? When you use insert into, what are you doing in CRUD? Are you reading? Are you deleting? Are you updating? Or are you creating? Insert into, right? When we do insert into this table name, values this, right? Column this, values this, right? 50/50, right? It's not update, right? See, update is when you do update, right? You say update table, set this column equal to this value. Insert into is you're creating, right? That's the create part. Okay, so you're creating it. Okay, so that must have displaced a lot of positions, right? Let's see. Okay, let's look at the podium. Ines is third, right? Ines is in the third place. Very well done. Ines Theodora, very close second, right? Well done. And in the first position with 7961 and clear winner Valentina. Awesome.